This week, we welcome Chris Morales, the head of security and analytics for Vectra AI, in our interview to talk about machine learning and artificial intelligence. In our second segment, we are going to talk about some of the, maybe a whole bunch of topics. There's 11 topics in there, which include favorite hacker movies, influencers in the security community, and what software or device makes appearances in our respective labs, and a whole lot more. Then, in the security news, cellular carriers are implementing services to identify cell scam leveraging. Wow. New Android malware disable security to mine cryptocurrency. I feel like I didn't add any of these stories. Those must be someone else's stories. That's why I was kind of... Anyway, a Nest camera is used to broadcast a fake attack alert, missile attack alert. All that and more on this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly. NetSparker, the developers of desktop and cloud-based web application security scanners that enable you to automatically identify vulnerabilities in your web applications and web services. NetSparker scanners employ a unique and dead-accurate vulnerability scanning engine that automatically verifies vulnerabilities with their proof of concept. For more information, visit them on the web at netsparker.com or email at contact@netsparker.com. Organizations' internal networks are overly permissive and can't distinguish trusted from untrusted applications. Attackers abuse this condition to move laterally through networks, bypassing address-based controls to spread malware. Edgewise abstracts security policies away from traditional network controls that rely on IP addresses, ports, and protocols, and instead ties controls directly to applications. Edgewise allows organizations to analyze the network attack surface and segment workloads based on the software and how it's communicating. Edgewise monitors applications and protects data paths using zero-trust segmentation. Visit edgewise.net/securityweekly to get your free month of visibility. Some restrictions apply.
Have you ever had one of those days when your InfoSec just didn't seem that fresh? Well, 4 out of 5 doctors say that Paul Asadorian makes your InfoSec go down as smooth as a bucket of warm eels.
Welcome, everyone, to Paul's Security Weekly. This is episode 591, recorded January 24th, 2019, right here in G-Unit Studios in Rhode Island. On my left is none other than the Dr. Doug White.
I'm here, despite the rain in Rhode Island.
There's a lot of rain today.
A lot of rain.
Weird weather. Yes.
But soon, we're hoping for that sea level rise, so I'll be oceanfront. Sorry, guys.
You very well could be.
Sorry, guys, down in the lower tier. I'm looking over, could you move your roof there? Because I'm going to put in a pier.
On the lines remotely, Mr. Joff Thayer is here with us. Welcome, Joff.
Who, me?
Yes, you.
All right. It's good to be here. It's a lovely Thursday evening, as usual. And, who else would I be hanging out with but you guys?
It's right. True. I just want to CD into hacky, hacky, hack. That's what I want to do.
Oh, especially after you make Dur hacky, hacky,
that's
hack.
right. And I want to do some LS. I want to do some LS in there, maybe even with a dash L. Beautiful.
Oh, man.
For those listening, I'm referencing Joff's t-shirt, which says make Dur hacky hack hack. Hacky hack. I couldn't see it. Yeah.
I just want to chone it. So
hacky.
He wants to chone it. Oh, yeah. Sorry, my microphone was intruding on my shirt.
Oh, boy.
It looks like it says something really nasty in Farsi when the microphone's blocking that out.
I know. Make Dur hacky what? Hacky what? Hack.
Also on the lines, Mr. Lee Neely is here with us. Lee, welcome.
Good to be here from Lake Tahoe at 7,800 feet where there's no oxygen. So obviously we'll be drinking to compensate.
And yes, you've opened up a bottle of wine. As of we. Ours is red. How about yours? That's the extent of my wine knowledge.
Well, there's four things to know about wine. There's white wine, there's red wine, there's wines you like, and there's wines you don't like.
That's true.
After that, the rest doesn't matter.
I like this philosophy.
But in the quantum wine world, there's also half empty, half full, and completely empty and completely full.
Well, now you're entering into replenishment.
Yeah, I love it.
That's the quantum wine world. So.
Make sure that you visit our sponsor, scythe.io/Security Weekly. That's right. Bryson came on a couple weeks ago. You can see a full demo of the product actually on the last segment that we did with Bryson. And you can visit scythe.io/Security Weekly and get a free trial.
Yep.
What's better than that? It's pretty awesome.
Awesome.
Another announcement, RSA is coming up March 4th through the 8th, rsaconference.com/Security Weekly-US19 to register now using the discount code 5U9SWFD to receive $100 off the conference pass. And if you're interested in booking an interview or briefing with Security Weekly, please go to securityweekly.com/conference request. If you work for an organization that is a security vendor that you think we might be interested in meeting and talking with and doing some stuff with, securityweekly.com/conference request. Send them our way. All righty. Here with us this evening is Chris Morales. I did say your name right, didn't I?
Yeah, you got it right.
Okay, good. He's the head of security and security analytics at Vectra AI, where he advises and designs incident response and threat management programs for our Fortune 500 enterprise clients. Chris, welcome to the program.
Thanks. I got to change whatever that says. I don't think I wrote that, and it sounds kind of boring.
I read a little snippet of it. Basically, your real introduction should be you're giving a presentation on machine learning and artificial intelligence at InfoSec World coming up here in April of this year. Is that that's your correct title at Vectra AI today?
It is, and it's funny because when I hear the description, what I actually do is I'm working with a ton of data. We're a data science company, so I'm quite literally doing data analytics and security analytics because I'm focused on security. And my only disappointment is that I couldn't find a drink with the rest of you guys, so I just have a cup of water. I just pretend it's something.
Just pretend there's more than water in there, or vodka if you want. So Chris, I guess to get things started and introduce yourself, how did you get your start in information security today?
Well, obviously, I think for a lot of us, we didn't know that security was a paying job. I started when I was a kid on VIC-20s when I was 12, and I remember getting online in the 90s, and the way on bulletin boards, you get more time to play these really stupid text games by changing the codes on software. That's what you used to care about. And then I dropped out of college. I was a comp sci major like everybody else. And I started internet security systems back in the late 90s when the whole joke was, where did you drop out of? And I remember them calling me. I was like, wait, this is a job? You actually pay for this? This is great. So it's kind of what I've always done.
That's awesome. So, Chris, we wanted to start by, it's been a while since we've talked about machine learning and artificial intelligence in this context, but I think there's a lot of misconceptions and people who are perceiving these two technologies or terms really very differently, right? There's a lot of vendors I think are overstating that they're using machine learning and AI in the product and what it really means. There are vendors that have machine learning and AI in their product that are doing a really good job of using those technologies. It still leaves most of the rest of us confused about what is artificial intelligence, what is machine learning, and how do the two differ, or how do they relate to each other?
Yeah, and it's a funny thing, obviously, because machine learning has really had a resurgence in the 2010s, so to speak, that there's a lot of new things that we started to figure out that it's really brought around this whole field of how to apply machine learning. But AI is just a term and a concept that started way back in the 50s. And simply, it was all about producing outputs that mimic human behavior. We're pretty fickle as humans because we keep changing what that means. And prior to machine learning, there were just all kinds of other ways to kind of create outcomes. Probably the most common one was something they called expert systems, where humans would quite literally take a skill they have and then translate for every single feature into the computer. And I think the best example of that was back in the 80s when they made autopilot. That was like amazing to people for airplanes, that they said, oh, this plane can fly itself from A to B. And that was an expert system. And people said, oh, well, that's AI. I think we're really fickle, though, as humans, and we keep changing our mind on what smart actually is. We can't even define what's intelligent for humans. So as we start to think of machines, we have trouble with what that is, which means that lots of vendors can simply say things like, I have AI, which reminds me of the world of organic food. When it first started, people said, oh, organic is good for you. Marketing caught on and said, oh, I'm organic, because no one defined it, until there were a set of rules to say, well, what does that really mean? So there is real AI, and the question is, what is it really at? And I always tell people, you just have to think of the outcomes. Like, was it something measurable? Did it improve a task? Did it make it faster? And did it actually learn?
Yeah, because I think a lot of security vendors, as an example, will promote the fact that they have that. But Chris's question is very valid. So what impact does that technology have on the outcome of what my product is supposed to do that I'm purchasing, correct?
Yeah, and you know what? Finding threats alone, that's actually pretty easy. Detecting things is what most people say. They say, I use machine learning so I can detect things. And when most people say machine learning, they're actually just doing anomaly detection. They're just doing it in a fancier way. That's not hard, and that's not new. That's not really intelligent. That's just machine learning.
Right. So just transitioning to AI for a moment, because I'm a huge science fiction fan, right? And it's all over science fiction movies for a long time. But is the Turing test, is that relate to AI, and what are some examples of how security can use AI today?
Yeah, the Turing test is still a real thing. It goes all the way back to that. So detecting things is a very technical thing. A very human thing is, what did I do with a detection? And so in security, it's not, I think the way I describe it to people is, we don't have a detection problem in this industry. We have a prioritization problem. It's less about what did we find versus what is it we need to work on and what's more important. It's severity. Anybody in security operations knows that there's tons of data. It's just, what's the right data? A way I like to think of that, a real story, is let's talk about Target. That's old, but it was a really interesting thing, because they did detect somebody coming in and somebody going out. And in fact, it was FireEye to drop vendors, and they saw malware_binary.exe. You know what? That's what they call everything, malware_binary.exe. The problem they have is that that's a generic name. It has no substance to it. And then you have maybe 200 other detections that happen in that same time period. So now, as a human analyst, you got to look at this and go, well, shit, I can only go through 40 things a day and I have 200. Which are the right ones to pick? And it becomes an issue where if they don't pick the right things, they lose. Sometimes you get lucky, sometimes you don't. So where a machine goes, and where this goes to AI, is when you start to think of tedious work and lots of it, and there's a lot of volume, it's not about replacing humans. It's about saying, you know what, going through that much data is a better suited task for a machine than is a human. And in fact, most analysts I know hate doing that work. It's really boring and tedious, which ends up leading to a lot of burnout. So if you allow a machine to say, I'm going to go through everything, and I'm going to start getting a better understanding of a behavioral approach versus just it was a malware_binary, and then build some context about the environment and what happened with it, and then start to score everything on how big of a threat was it and how sure am I this is a real problem, you start to build a better scope that you can tell the human that, hey, you had 200 things. These two right here, these are about to kill you and put you in the news and cost you $200 million. You might want to look at that first.
And Chris, what is the difference, or how do the machine learning and artificial intelligence relate to each other?
Machine learning is an enabler for artificial intelligence. It's again, so if an expert system was manually programming a system to do a human-based task, but it was very static, machine learning is simply taking a machine and letting it learn from sets of data. Humans still have to do work, though, and they classify it. You know, I guess the joke is that a machine learning algorithm walks into a bar and goes to the bartender, says, hey, I want a drink. And the bartender asks, what kind of drink do you want? And the algorithm says, what is everybody else having? What is everybody else having?
Chris and I were talking about that joke before the show, and I stole it from Gene Spafford.
Did I get that in there?
I did. That was a great segue into it. I have to give Gene Spafford credit for bringing it to my attention, and I thought it was funny. And Chris and I were doing a prep call earlier, and I'm like, I saw this great joke on machine learning. Like, we totally have to make sure we tell it tonight. So.
But the AI in that joke, the AI goes, "I'll have the whole bar. Have a nice day," and it just takes
Consumes everything.
Wipes everybody out.
I think the real problem with AI that people have is that they watch The Terminator too much. I love the movie, but AI can't think for itself. So it's artificial intelligence doesn't mean it's smart. It's there are two ways to look at AI. There's general AI, which is a machine's going to wake up in the morning and make life decisions, which is kind of scary if it wakes up and go, why am I listening to these people? I'm smarter than them.
Right.
We don't know how to build that.
That's the premise for countless science fiction movies, by the way. Don't ruin it for us, Chris, that like those movies. Let us go on believing, okay?
Hey, you know what? That's still the dream. We're just not there. What we call AI today, which marketing does not like the phrase, is called narrow AI. And there's nothing sexy about the word narrow. It's really a task-oriented AI that it's a high level of automation of like a task. That's what we can do. We can automate work and make it an adaptive automation, but we actually don't know how to make a machine smart yet.
So,
Lee?
So I'm thinking about what you're building with and modeling, and the question is, how do we avoid a false negative so that we don't wind up sweeping the real things under the rug?
It's not about false negatives or false positives. That's also a very classic security what I miss or not miss. Machines are about numbers. It's all statistics. And in fact, the thing about data science is that you have to ask very specific questions and then fit it into a model. To even go farther, there's only 5 questions you can actually ask in data science, and everything has to fit into that. And the questions become, is this A or B or C or D? How much or how many, which is a quantity question. What should I do next, which gets in this regression? Is this weird, which is what a lot of anomaly is. And how is this organized? I knew I was missing something. How is this organized? And the reason I bring this up is that when you start asking these questions, the only thing the machine can do is bring back data on that. So if we think about is this A or B, for example, like, is this good or bad is what people want to ask, but you're not really asking that. You're asking, is this external remote access or is this not? And is this a web session like what we're doing now? Is this a podcast or is this somebody trying to get into my network? It's not about throwing anything out. It's about scoring everything based on that whole scale of threat and certainty, because machines assign numbers to everything. So the question becomes, was this a score of 0 or a score of 99 based on what factors and how did you decide that? So nothing gets thrown out. You just score things and bubble up things with higher scores.
So how many people do you think don't get that?
Most. Here's a way to put it. The reality is we don't know. A machine doesn't know if it's an attack. A machine is predicting an attack. A human still has to decide if it's real.
Right, and that's cool. I just was thinking that people think about it. They don't think about it the way you're describing it. And part of the trick with machine learning is educating people on how to interact with what the machine is doing.
That's
it's
actually
not
really
just killing
important.
your
You have to write a process, but here's the big takeaway I learned. People like to stick in AI and then they sit there and go, well, it didn't do anything. And I'm like, well, you still have to do something. It's not really replacing humans. That's kind of a myth.
Hey, so I got a question.
Go ahead, Josh.
I know. I still have to show up to work every day. If I could write an algorithm to replace me, I'd go to bed.
Go ahead, John.
So there's multiple different ways to implement artificial intelligence or machine learning algorithms. Do you find yourself leaning towards the more traditional modeling approaches, which are, feature classification using things like random decision trees or decision forests? Or do you find yourselves, implementing things more in the neural network sort of self-learning mode? Or is the answer both?
The answer is both, all the above. And I'll go even farther. Sometimes machine learning is overkill for a problem. Not everything has to be fancy, right? So there are simple things you can figure out. But you have to start to look at every single problem individually. I'll think of behaviors, so a lot of things that happen on the internet, like, let's say we know attackers use Tor traffic all the time, or we know there's an external remote access. These are global problems, and there's global data. You can actually train using supervised learning, using classification systems and regression to start to figure out these are consistent across all environments. In those effects, you can start applying deep learning and neural networks to that, because you come into the human problem of a human has to be able to take all kinds of external remote access, and that's malicious or non, and start to describe features and figure out what it is, where the machine can do it much faster. So if you have enough data, deep learning works great for that.
Okay, so just to sort of re-ask a question here, or maybe clarification, is what you're saying that while you might start with a certain number of assumed feature classifications in more of a decision tree model, you may feed that into a neural network to actually refine the feature classification to kind of bring you back around into a decision model. Is that accurate?
That's actually exactly accurate. It's a decision tree using a neural network to refine the features.
Excellent. I love that. I'm quite interested in the topic, and I have not dabbled in neural networks. I've definitely dabbled in decision trees and decision forests using the Python APIs, and I think there is application there. But some of what you're saying is there's definitely a tendency for people to over classify in terms of feature classification, and also even over implement, where you may not need an AI natured algorithm when basically a simple computer algorithm is good enough.
Yeah, well, yeah, you could take some. Let's take port scanning. We figured that out a long time ago. I think we figured out how to figure out if it's a port scan pretty easily. Or let's take crypto mining. You know what? You just have to look for the Stratum protocol. It's used by every single one of them. It's not that complicated.
Right. And there's a distinct signature of it on the wire. There's a distinct, footprint. You don't actually need to do any predicting, is what you're saying.
Exactly. Like it is or it is not. The other thing is an example where classification really starts to fall apart in supervised learning is when you try to understand the internal environment. You don't have enough data to train on who's administering what servers, and do people use Dropbox or OneDrive, because it changes so much. That's an area where clustering, which is unsupervised learning, makes a lot more sense. That you want to learn on that data in real time.
That's interesting. Is that not also an example of almost overfitting or trying to essentially apply the wrong approach? Like you said, you just end up in a clustering approach, which is more of a statistical approach, which is an alternative to a feature classification, which is more of a yes/no kind of approach.
Right. Well, no, for local environments, clustering actually works. So I use clustering so a lot of people are doing anomaly detection. They're trying to say, let me learn your environment and see what's different, which is stupid, because different is every day you hire a new person, you change an app. Things change, right? Clustering is building domain models, and it actually works where I can start to figure out who's administering which servers, where they do it from, when they do it, and start to make predictions about the user. And honestly, Facebook does clustering today, and so does every other advertiser, Google. It's a technique the marketing world has figured out a long time ago. So they figure out if you're into basketball, they could pop up an NBA All-Stars video game ad for you in real time. You can use the same techniques to figure out not the negatives, you figure out the positives, so that you can start to see, well, this guy is not part of that admin group, and this guy usually lives in New York, he's not in LA. You can start to see those variations and then score those.
Are we seeing hold on, Jeff, wait. So I'm sorry, I just want to go back for our audience, the difference between supervised and unsupervised learning. As this is important for those of us in information security today, evaluating solutions and such.
Yep. Yeah. So supervised, I'll give it in a mathematical. So the difference between supervised and unsupervised is about the data you have. So you have X and Y. X is input data, Y is output data. What supervised really is trying to teach a machine to come out with a very specific outcome that you already know. Tor traffic is another super easy example. I know what Tor traffic looks like, I have input and output data. You keep feeding it input data until it comes out with the results you expect, and you keep tuning the algorithm till it knows that. Unsupervised works when you have no Y. You have X and no Y. You have input data, but you have no idea what the outcome is. So you have to start making predictions on what it is based on different attributes.
Mm-hmm. Gotcha. That's awesome. Thank you.
Yeah, that's really good to bring that out, Paul. Sorry, I was geeking out a little bit. But,
I know you've had experience with some of this stuff, Josh, so I want to make sure that our listeners
would
understand.
Unsupervised include things like pattern recognition in large data sets where you don't know the outcome, you're just looking for, I've seen that a lot.
The input, the outcome when you're analyzing.
I've seen a lot of like big data stuff where people were looking at massive data sets that are really just too large for humans to digest, and they were just turning these things loose on it and saying, find me a pattern, and it comes back and it says, wow, if you do this, you'll do that maybe, and weighting all that stuff up.
Yeah, pretty much. There's a lot of predictive outcomes out of unsupervised. A great use of unsupervised, which gets into the automation stuff, which actually is something we use. So see, I could talk about every single they all have a purpose. Now, a lot of the Bayes stuff that you hear get thrown about, that's actually good at predicting outcomes based on an input set of data. A really good use of that is
sorry, Chris, which one was that? Because there's different types of, what we're getting into is basically the different types of machine learning algorithms and data science, correct?
Correct. So I said Bayes, B-A-Y-E-S, that gets used a lot. It's actually what people use for anomaly detection. The irony is I think it's a good algorithm, it's just poorly used. Mm-hmm. What it's actually, Bayes is, in simple forms, you got X amount of data and you're trying to predict Y outcome. What we've learned is it's actually really good at predicting an attack based on certain inputs if you score all the inputs and then you score the outputs on that. And that's where I get into the whole, it's not about false positive, false negative. It's about threat and certainty.
Yeah, I think that the other point that's with that, just to chime in, is I think you're right. Bayes gets misapplied. And data science is all about modeling ultimately, and you got to fit the right model to the right problem. And I think that's a large part of what you've been circling around. You talked about clustering. Algorithms such as k-means clustering are better suited to certain problems versus things like random decision trees or regression analysis. And I think there's a tendency for inexperienced data scientists not to think about fitting the right algorithm to the right problem. And that definitely shows in some of the misapplications. I think Bayes is a really good example because it became very, very popular in the email world when there was a lot of success for spam classification. And so I think there was a sort of generation of people that thought Bayes is the right solution for all my AI problems.
Yeah, gonna fix the world.
Yeah.
Do you know what? I think that problem is, though. You're right. The data scientists aren't asking the right questions, is what it comes down to. So they're overfitting. And I realize it's because they don't know the questions to ask. Data scientists are math experts. You need security guys to guide the data scientists to tell them what to do.
Actually, that's something I was wanting to zoom in on before Paul got me out of my geek moment, and that was the characteristic feature classification issues, and something that I found in experimenting with some algorithms around DNS work is if you overfit when you're doing supervised training, when you're doing modeling with good data, bad data, then your model ends up being too precise. And you end up with essentially a useless result. You can't predict anything because you have overclassified in your training. Can you speak to that a little bit?
Yeah, no. So I agree with you. It's that gets really tricky. And again, I reiterate, it's the data scientist doesn't really know the data half the time, and the overfit comes because they're not sure of the outcome. You really need a security researcher to guide and manage that. And you have to be very specific about the problem every algorithm solves. So it's really actually better to write smaller algorithms than it is over-encompassing algorithms that are supposed to do everything. So you, even on an unsupervised algorithm, you really want to define the parameters of what the outcome is to be a small chunk, and then layer that in with other algorithms. The trick is to start combining them, doing each very specific job, and then scoring it. So saying, yeah, this happened, but how much did it happen, or how much did I care? Then it's applying it to the right features. It is a real issue.
And that's where the neural net picture starts having all those arrows going between all the different nodes and everybody, because that's what you want, is each node needs to be taking everything else into consideration.
Yeah, well, here's what's funny about the neural nets and why I feel like it's safer on supervised learning, because if you know what the outcome is supposed to be, you can keep retuning your data till you get the right outcome without actually knowing what the neural net is doing.
Right.
But the ultimate thing there is you have to know exactly what the outcome was, and somebody has to understand that well. And just this is kind of funny. I sat around the office and I've watched it, and I realized what the process for security is a bunch of dropouts yelling at PhDs that they don't know anything.
Oh, that is so true. That's awesome. That really tickles my anyway.
I have no comment.
There's one other question I wanted to pose to you, and that was, you already mentioned that you're using neural nets on the tail end of feature classification, supervised learning approaches to kind of inform those approaches. Do you also find yourself using diverse sets of supervised learning with multiple different features, essentially multiple models, and averaging out the results for a better clarity, or does that approach not work?
No, so to be clear, we already have 60 different models today. So yeah, we have a ton of models. What we're finding is every little one does something different. In some cases, there's a little bit of layering, maybe 2 or 3 deep, but it's not like massively deep. Let me think of it. Here's a good example. Actually, this is a funny trick. I don't even know if I should share this. So take remote desktops, right? There's 2 things you want to look for. First, you want to say, does a remote desktop exist? Then you want to start to clarify, like, and is this a legitimate one, or is it somebody misusing it? So you can use a really simple classification system to figure out remote desktops. There's nothing that fancy about them. But now you have to start asking yourself, well, what features am I missing that starts to clarify if I should care or not? And an example of that is we learned the keyboard is a defining feature. So our remote desktop is a good problem for supervised learning, but learning a keyboard, and if it changed, means you need to first learn what is the normal keyboard for the company, like is it English? And if it changes to Russian, is that different? And that's an unsupervised problem. You can actually combine those into a single model and say, okay, first, I know it's a remote desktop. Second, I know that they use an English keyboard, and now I see a Chinese or a Russian one. That raises its threat score, because that becomes a big indicator of compromise, and that's multiple models working together.
That's really cool.
That's a good example. I like that.
Yeah, it is.
Stolen.
Yeah.
Okay, I'll stop asking questions now. Back to you guys.
You can carry. So I guess, Chris, what are some of the other more common machine learning algorithms that are in use in security today?
The most common thing used today, and you heard me say before, is actually Bayes, by the way. I swear Bayes just jumped on that. And they're using it for anomaly detection. A lot of the things we're doing, most people are simply not doing yet. They're not. I can only think of 1 or 2 other companies that's actually using deep learning today, other than us. One of them put their whole name around it, which they overfitted. I'm not going to say who it is, but they use deep in the name of the company, and they use it for endpoint. They say it's going to fix everything. And I'm like, well, you just overfitted again. You assume that by using deep learning and then pitching that's going to fix the problem. Other than that, I swear it's mostly Bayes, and it's not used heavily. A lot of times people are using a machine learning light, which they're using it for small tidbits, and then they're combining it to actual what looks like signatures. I mean, it looks like snort signatures to me half the time.
This all sound. I mean, all this stuff I agree with. It sounds a lot like statistics and regression there was a. I mean, I don't mean it's the same thing, but regression was
based on that.
Well, but I mean, regression was one of those things that like came out. All of a sudden, everybody had it. Every product had to have it. Everything had to have regression. And the overfitting problem is such a good thing to point out, because that was such a common thing with statistics, was people want to overfit everything, often because they know a desired result, not necessarily the real outcome, but they have a desired outcome, and they overfit the models like crazy, and all of a sudden everything had regression. Nobody understood it. It was misused. All the assumptions were violated. I've seen that over and over and over again, and I see that a lot now with AI machine learning stuff. Same kind of thing, and you see the same kind of dialogue, the same kind of marketing, and the same kind of behaviors.
And they really, people start to market the algorithm like it's going to solve all the problems. Like regression, to your example, really good in the real estate world. It's really good at predicting a value of a house in a neighborhood based on other houses and what they sold from the neighborhood. That would, like in security, if you use regression learning, I'm thinking to myself, okay, so I need to count how many times you were attacked and then start to predict if you're going to be attacked again, which is an insurance problem. I don't see how that works to solve an actual security problem. So yeah, it's like, it might be a cool algorithm. It's the wrong place.
Marketing.
But it sounds good as long as you use a lot of big words and
as long as it's sexy as hell, everybody will buy it. It's like,
then it's great.
Well, I think Doug's right. We're going through this period where AI and machine learning are the sexy marketing algorithms, and so it's almost like what the data scientists say doesn't mean anything unless they say the right words at the right time, coincidentally, right? So
I'm telling you, it's just, and it's, you see, now contains logarithmic regression, you know, and you're like, do you actually know what, you know, what, or Lizral was another one. I mean, it was like, now with Lizral capabilities, and everybody was like, oh, you can do Lizral with it. And then I'm like, yeah, but it's not for that. But yeah, but it has it, right?
You throw that in a few, you know, C-level magazines, and before you know it, it's like, oh yeah, that's the thing I need to ask for, you know.
it's like convincing people in Los Angeles they need Maseratis so that, you know, they can sit in traffic in a Maserati.
It's true.
Yeah.
So they buy a Tesla.
You know where we think the industry is at those? I remember, I don't know why I remember these, but like, it was maybe 20 years ago, IBM. So IBM is brilliant at commercials, by the way. I love their marketing. They're so good at this stuff. They had this commercial, like, it must have been 20 years ago, and they had this guy reading a newspaper, and he's like, it says here, we need to be in the cloud. And the other guy goes, oh, and he goes, does it say why? And they're saying, go, no. And then it goes to their ad, and I laugh, and I think that's how AI is today.
I agreed.
Yeah, they're like, we need an AI project. Why? To get us ahead. How do we use it? I don't know.
Why aren't we doing AI? More of it. Yeah. I've had that question. Like, why is our company not doing more AI? Why do you think that's important? And it's like, what do you need it for?
What is the problem we're trying to solve? Empty box AI.
I love it.
It's task automation. It's not actually intelligent. I'm okay saying that. So that's why we have like 60 algorithms, because we look at every single task and say, you need this for this, you need this for this. And by the time you're done, you need humans to build it, and you need humans to use it. That doesn't go away.
It's very true.
And do people understand what build it means?
No. They don't know what goes into building an algorithm. I mean,
no,
I don't think they do.
I don't think so.
Time for Dummies book?
Oh, no.
Yeah.
Oh, no, please don't.
Did I say that out loud?
AI algorithms for dummies. There probably already is one of those.
Probably.
Yeah, I'm
not,
guessing they're...
I always just tell people to watch the Silicon Valley episode of Hot Dog Not Hot Dog and download the app.
There you go. You got it.
That was pretty accurate.
I 100%. Yep.
I didn't see that.
You never watched Silicon Valley?
I did, but the algorithm that I'm thinking of is at the end of season 1.
No, not and that algorithm.
What is that one called? I can't think of the name of it now. There's people screaming at me now in their cars because they can't. It was double in and out, double.
The double, yeah.
What is it
something
called? Someone.
I don't know.
I can't help you, Paul.
I don't remember the name of it. I'll think of it in a minute, or I'll look it up.
Oh,
you know, you can download the hot dog phone from the App Store. They actually.
What was the Hot Dog Not Hot Dog? Explain that without ruining the episode.
They came up with an app pitch that it can identify hot dogs and other things, but all it could actually do is identify as a hot dog or not a hot dog.
Oh, so that's awesome. It's
Oh,
middle out compression was the one I was thinking of.
That's it. Middle out compression.
Quite
Perfect
possibly,
example of buzzword marketing.
being a nerd, that is one of the funniest moments in television history. Is the entire scene where he starts to they go in the hotel room and they start talking about that topic,
The compression
all the way
algorithm,
to like winning the that is like the funniest
No, I
moment
had to
in
stop
television.
it so I could laugh, which is very unusual.
I've never laughed so hard at a
It's
TV
just like I
show
had
in
to
my
stop it.
entire
Yeah,
life.
yeah.
It was anyway. Sorry, we're talking about algorithms and that
Oh
middle out.
no! I live in San Jose, and I watch that. And go, oh, this is the documentary.
Yes,
Yeah.
that's what a lot of people tell me that live in Silicon Valley. So
Yeah,
fantastic.
Middle out
Chris,
compression.
anything else you want to tease for your upcoming talk at InfoSec World?
I think we covered the bases. It's just I found like we put this together because it is such a problem that I don't even want to claim innocent as a company. We do data science, but there's like a list of questions you have to ask, and like you shouldn't buy or do anything because it sounded cool. Like deep learning is funny. It's actually really hard to use, and it needs to be very focused and narrow and used properly. Used otherwise, it's got a lot of time and effort. In my talk, one of the things I actually do show the development cycle. I'm not afraid of showing what it takes to build an algorithm and what are the steps, who's involved. Finally, one of the last things I like to talk about is providing a list of questions to people that you should be asking. Every single person that claims AI or machine learning, including us, like there needs to be some accountability.
Absolutely. Chris, are you ready to play 5 questions with Security Weekly?
Sure.
Oh, I might have forgotten to tell you. Oh, actually, no, we don't tell anyone about 5 questions until it is time. And now it is time for 5 questions.
We're going to
Security
predict your
Weekly.
answers.
That's right. 3 words to describe yourself.
I am me.
If you were a serial killer, what would be your weapon of choice?
A rope.
If you wrote a book about yourself, what would the title be?
I am me.
In the popular game of Ask Grabby Grabby, do you prefer to go first or second?
Say that again.
In the popular game of Ask Grabby Grabby, do you prefer to go first or second?
Very popular in Europe.
Especially Eastern Europe.
Second?
Oh, I was
You know
really...
what? I don't know the answer to that.
I think you should write a machine learning based algorithm
To predict the answer.
to predict
Yeah,
the answer
You
of Ask
need
Grabby
some Ask
Grabby
Grabby
first or
Grabby
second.
protection.
I would have to take enough people doing it and take a sample of it and then see what's the better outcome.
But you got like 500 episodes of Security
That's right.
Weekly.
We've
You just had
asked
to
a
go
lot
through
of
them
guests
all.
that. We'll get
Yeah.
you the data, Chris.
Yeah.
Be awesome.
Get you the day.
It's the
That
Ask
would
Grabby
be-
Grabby data set.
Final question,
Yeah,
Chris.
that'd be good.
If you were to choose 2 celebrities to be your parents, who would they be?
Alive, dead, fiction, or otherwise. Well, that's tricky because first you start thinking of like who are the celebrities you want to hang out with and be fun. Then you realize they're not necessarily the best parents, are they?
True.
That's
Or
true.
are they?
Are they?
There is no wrong answer to this question, Chris. Just,
There is a wrong answer. to
No,
this
there
question?
is no wrong
No,
answer.
there is too. It involves Kanye. So
No,
So,
come on.
Chris
His
is like the
early
classic
stuff was
scientist.
good, as
You know
long as
what?
you clarify.
I'll be self-serving then. How about Bill and Melinda Gates?
There you go.
there you go.
Oh, yeah, you got it.
That's fun.
Now you can build some real stuff.
That's right.
It's like an island that thinks for itself.
That'd be great. They have the resources, the money, and the intelligence.
Right.
So, hey,
Awesome. Chris, thank you so much for appearing on this episode of Paul Security Weekly.
absolutely. It's been fun, man.
And with that, we'll take a short break. Come back for our topic discussion, not to be missed. We're going to answer questions, not the 5 questions, but we'll answer questions.
More.
Endgame's converged endpoint security platform is transforming security programs, their people, processes, and technology with the most powerful endpoint protection and simplest user experience, ensuring analysts of any skill level can stop targeted attacks before information theft. Endgame unifies prevention, detection, and threat hunting to stop known and unknown attacker behaviors at scale with a single agent. For more information, visit endgame.com. The average time between being hacked and realizing you've been hacked is 1 year. Can you afford to let an intruder roam your network for that long? Can your company weather the fallout when this comes to light? Black Hills Information Security can find the bad guys in your network and train you to do it yourself. Email consulting@blackhillsinfosec.com to find out how a hunt teaming engagement can help you find a persistent threat in your network.
Welcome back, everyone, to Paul's Security Weekly. Let's see. I've got an announcement, which I think... Oh, it's coming up. Hold on. I do have an announcement. Yes, Recorded Future is one of my announcements. Visit recordedfuture.com/Security Weekly for all things Recorded Future. They will be coming on the show this year at some point. Very happy to have them as a sponsor, Boston-based company. Great company, and great services that they provide for free. Like if you go to recordedfuture.com/Security Weekly, you can subscribe to their daily email of threat feeds. So you get a threat tip every day, which I think is cool. You should do that. Anyway, did I have other announcements? Oh yeah, of course, InfoSec World, where Chris Morales, myself, and a whole bunch of other people from Security Weekly are going to Disney's Contemporary Resort for InfoSec World 2019. That's right. You can go to infosecworld.misty.com, use the registration code OS19-SECWEEK, 15% off the main conference or World Pass. If you're interested, again, in doing a briefing or interview with Security Weekly, please go to securityweekly.com/conference request. If you work for a security vendor and you want to see them engage with Security Weekly, tell the team, send them there, securityweekly.com/conference request. And now we're going to talk about stuff. I like these segments because we were like, oh, crap, we don't have a technical segment. And the technical segment I had was more appropriate for Enterprise Security Weekly. So you can listen to it there. And then tonight we are talking about, I have 11 topics.
Oh, my God.
Do you want to start? Does anyone have a topic they want to start with? Do you want to pick random? We can't really pick random numbers because everyone can see it. I suppose I could get a random number. It would only be pseudo-random anyway, so what's the point?
Oh, my. Let's know. Are we going to go there?
Let's
Where's the neutrino detector? Get the damn neutrino detector. I need it. All right, no.
I thought Joff was going to say, I was pausing because I thought Joff was going to say something.
Oh, well, I was just muting myself again because I was like, they're just ignoring me. But,
Joff,
yes, pseudo-random.
Joff, how did you get your start in information security? I don't think you've ever talked about it on the show.
No way. You're really asking me this?
I'm really asking you that, yes. Imagine that.
Okay.
This is the beauty of the topic. We can say whatever the hell we want now. I love this segment. I think
it's beautiful.
It's beautiful.
It's beautiful, man. It's beautiful.
Actually, so does anybody remember, this is related, does anybody remember that time when there was sort of a split between sort of systems and networks people and information security? There was a distinct period of time, probably
yesterday, or
like this morning.
In some organizations, maybe as early as this morning, John.
Yeah, that's this morning.
Yeah, maybe it's never happened in some organizations. But so how did I get my start? Well, it really happened because there was a period of time back in my university days, and Paul's really familiar with this because he was a university person as well.
I was in the University Days movie with security people, yes.
That's right. Where always in the systems group that I was in, my boss was very, very interested in information security. In fact, that was his primary focus. And when the amazing organizational split period occurred like this, right? I ended up on the operational.
What was the split, Joff? Because I do remember working in university from 2001 to maybe 2007-ish time frame is when I worked for the university.
Yep.
That where there was multiple shifts. Like everyone said somewhere that security should be part of the systems administration group, and then everyone said, no, that's not right. Security should be part of the network group. And then they said, no, that's not right. Security should be part of the information security office. And they said, no, that's not right. Let's go back to network. We were all over the place, Joff.
No, it was totally all over the place. And it turns out, okay, it's just this is turning into a long story, but
that's okay. We got time.
By an accident of the fact that I was into systems administration at that time with Sun Solaris systems, that I ended up building networks because in 1999, does anybody remember that period of time where Ethernet could not be transmitted over optics? At that time, it was all just thin wire or very short distances. Okay. And there was a bridging technology that emerged, and the bridging technology was ATM. And ATM was the only optical technology that was available to get you over more than 1,500 feet.
Yep.
And most universities were large enough from a campus perspective that they needed to get over those distances. Well, this is a long way of saying that we embraced a technology that actually used a route server to make the routing decisions, which was a Sun Solaris system. And they looked around the shop and they said, hey, who knows Sun Solaris? And my boss said, well, Joff does. It's like, okay, he's the network guy. So I became a network guy just by virtue of the fact that I was fucking around with Sun Solaris systems.
But you know, Joff, before you go on your story, looking back on it now, I really think that we're blessed to have been moved around to all of those different groups. And I'm not sure if you hit all three. I definitely did the trifecta, right? I was security guy working in a sysadmin group, security guy working in a network group, and security guy working in a separate security group. But the beauty of that is the experiences that I gained, not just from understanding the dynamics between those groups, but gaining all of the knowledge from systems and network was hugely valuable. Like, I almost think there should be programs where interns do time in all of those different. It sounds like prison, right? It depends if you're doing Windows or Linux or Unix systems administration. Whether it's minimum or maximum security prison somewhere in there, you can rank those how you see fit. In any case, I think it's beneficial for folks to have those experiences.
Oh, there's no doubt at all. In fact, I wouldn't trade it for the world because, in fact, I've had people come up to me at conferences and stuff. Well, I want to be like you, or I want to be like a John Strand, or I want to be like a Paul Asadorian. Then how do we do that? I was like, well, you put in your time. Well, what do you mean?
Lots of cigars and booze. Oh,
yeah. And then I sort of unwrapped the box. I'm like, well, I went through all this period of systems admin. I learned how to hack systems up and down and understand the Unix system. And once I learned how to do that, then I became a network guy, and I learned everything about packets there was to know. And I spent years doing that. And actually, this comes back to my story. What I learned very quickly in a university setting was the enemy are your students, because they will attack the infrastructure.
True.
Okay. Love them. They're our customers as well, but they attacked the infrastructure. And so you learned very quickly that if your network infrastructure was not extremely resilient and robust, it was going down. I mean, it was straight up denial of service, right? So I developed a number of techniques, and I learned as many features of different software sets to defend the infrastructure as I could. So my experience was crafted out of defending the infrastructure from denial of service, largely, in that context. But I had all this great systems background as well. And then towards the 2011, 2012 period, I started to move out of that. I wanted to move out of that state government state government career, because basically the money fell out. Everybody remembers the recession of 2008. We all went over the cliff, and a lot of state agencies suffered dearly at that time. In fact, I was going to get out in 2008, but I ended up waiting because of the recessionary period. But I always wanted to go back when that split happened organizationally between security and operations, and I ended up more on the operations side, even though I was engineering and doing security operations, because that's ended up being my job. I was engineering defense. I was doing IDS, IPS. I was doing all the operational side of security. I always wanted to be in a security group and dedicated to information security as my job. And I engineered my way out of that particular period of my life. And it was DerbyCon. The next thing that happened, and this is why I was so passionate on our last episode about what Dave has done for the community. The next thing that happened was I started networking as much as I could through a combination of information security conferences and SANS training. And that's really what got me jazzed up and headed in the information security direction. There was a lot of Mike Poore and Ed Scotus in the early days, 2008, 2009, 2007 actually as well, where I spent a tremendous amount of time and spent some state dollars getting training. And I literally trained myself out of my job at that time and eventually moved into working with John Strand at Black Hills, which is a really fantastic thing. So that's kind of my journey, a long story, right? So,
I love that. I love that Joff is also a packet nerd as well.
Yeah, I can talk packets. There's a guy that does talks at cons quite frequently, Paul somebody or other. I can't remember his last name. And Paul, I really apologize if you're listening. But he does a lot of BGP talks. He does routing protocol talks. He does, network defensive talks. And we had him on the show at one time, Paul, Southern guy. I forgot where he lives now. But it was fun when he was on the show because we got to sort of talk packets and have a lot of fun with that, because I spent a lot of time not only engineering enterprise network level at the university, which is 13 to 20,000 subscribers or endpoints, but also scaling up. And I ended up consulting a lot for wide area as well in the 250 to 300,000 scale in terms of endpoints, in terms of subscribers. And so I got to see some things that, your regular local area network guy probably wouldn't normally see. So that was really valuable. So that combination of really deep systems administration experience and huge exposure to networking, combined with my existing skills with application development, that's sort of the trifecta for me that led me to information security because of my interest as well. And that kind of background is just a huge enabler.
I wish I could keep some of that information fresher in my head. As I sat in front of a Cisco switch this week and I was like, shit, I don't remember. Like, it's sort of coming back to me, but then I'm like, I get into the more advanced stuff, like, how did I create like I used to have these commands on the top of my head.
Yeah.
Now I gotta look them up, like how to create VLANs and trunking and all that stuff. I'm like, how do you set the? I'm like, I know what I want to accomplish. I know the lingo and some of the commands, but the exact commands are gone because I haven't been doing it lately.
Yeah, so I had to get very deeply into defending the network infrastructure from the perspective of defending the control plane on pretty high-end devices, right? You're talking about your Nexus devices. You're talking about your Cisco Cat 6500 series, which was a very long-lived series after the 5500 series. And if you didn't defend them appropriately, so in fact, I'll give you this is again, a denial of service example. If you're able to send a packet into a network and decrement the TTL so that when it hits the router control plane, it only has a TTL of 1, it will always be processed on the control plane and not in the ASICs.
What's the max value of the TTL in IPv4 header, Joff? I'm just going to ask you trivia questions.
255, right? Yeah. But
thank you.
It's an 8-bit field.
8-bit field.
It's an 8-bit field. But if you manage to hit the router control plane with a TTL of 1, especially with a highly fragmented packet, that routing device is going down without a doubt, right? Because what happens is TTL 1 is down to, I'm going to drop the packet. And that decision is something that cannot be made by the ASICs. And so it goes up to the control plane, which is a software processor. And the software processor is not built to handle traffic at volume. And so you just keep hammering that thing with packets the appropriate TTL, and it's going down without a doubt.
There were so many. You talk about Cisco 5500s and 6500s. I felt like they were really fragile back in the day. Like, I remember troubleshooting issues, and sometimes, like Joff said, it was like legit DOS attack or just trying to process weird traffic.
Yeah.
I feel like stuff is a little more resilient today. I don't know.
You know, I think it is, but the thing people have got to realize is, I don't know what the state is now. It might be interesting to have a Cisco person come on and talk about it, but back in the day when those things were being engineered, and we're talking 6-8 years ago now, those they were engineered with just the minimum specs in terms of processing power. They did not over-engineer them. It was just enough processor, just enough memory in each of the queues for the network interfaces, according to best practices at the time, right? And there's a lot of actual computer science that talks about router queue and the stochastic effects of TCP buffering and its impact on the internet. I did actually a whole research paper on that.
Nice.
But it was minimum engineering because they wanted to get maximum bang for the buck. Like any company, they were not going to deploy too much hardware out there or too much software out there, just enough to get the job done. And so the ramifications of that, and they did realize in the infrastructure world that they needed to provide control plane policing because the control plane was vulnerable, due to this minimalistic engineering.
Doug,
and it's cool.
Sorry.
I get it. Right.
Sorry, John, I didn't mean to interrupt, but I wanted to also ask Doug. I know, Lee, you've answered the question, how'd you get your start? Doug, I don't think you ever talked about how you got into security. I mean, obviously you were studying computer science in school, right?
I was drunk. No.
I was that the whole time, too.
111 years ago, when I was 10 years old, that's a movie quote. Well, interestingly enough, what Joff was talking about with these splits and all these things, I was on a different wave of this than Joff. So
that's because you hung out with Lou, let's be honest.
I didn't know Lou at that time. But yeah, when I was in college, I was a sysop for PDP-11. And
wow, you are old.
Yeah, well, it was actually being end of life, but we switched to DEC 10. And I also was a sysop for IBM mainframe. And like Joff said, one of the things at the university was that the students really went after these devices. And honestly, at the time, security wasn't really a thing. It was more of a like gamesmanship sort of world. And
you ended up hiring the students that hacked into your stuff.
Yeah.
Because their intent was just really nothing. It was just curiosity. Well, and you're like, well, you're curious, and wow, you're really smart. You learning the stuff on your own. Like, you should come work for us.
And it was a nerd effect in that everybody that was doing all this stuff was in the game. You know, and until the world changed and all these other people got involved, most people perceived security was just a bunch of nerds messing with each other, and so therefore it is of no concern and we shouldn't spend any money on it. But when I first started working on the mainframe, I started writing scripts that, the initial scripts I started writing were looking at traffic on, and these were pre-TCP networks, they were proprietary, but we were looking at traffic on those networks for certain behaviors. And just like one of the scripts I wrote really early on was just people trying to escalate privilege. So I had this thing that I called the shit list of user accounts that was automatically built for me every day, that I wrote this script, and it watched for people to type certain strings on the mainframe, and it put them on the shit list so that I would know who they were, because I was like, people that know how to type this are trying to escalate privileges. They're trying to change into other people's directories. They're trying to create pipes and links into other places. So they must be trouble. And so we actually went after them. And that was how I kind of initially got into security, from the perspective of, I realized this was an issue because we were seeing expansion in who was using the systems. And when I was first using computer systems, there was 9 people on them. You know, all of a sudden there was 900 or 9,000, and it got to be a really complicated problem because these people were taking the system down. They were causing issues. They were stealing people's stuff. They were playing jokes on people, and it got to be really ugly, and it turned into a mess for our job because we were trying to keep the lights on, and we come to work every day, and somebody's like, oh, my God, you know, that whole file structure got corrupted by somebody, and we don't know who. And it started being like, how do I stop these people from doing it? Because there was literally there was no security, really. There were backdoors and our logins and all kinds of things equivalent on those systems that had been built by the engineers that designed the systems who left those holes in them. And all this early stuff you heard in hacking So if you go read those early things like the
Clifford
Happy
Stahl.
Hacker's Guide to Happy Hacking or whatever that thing is.
Kukazag.
Yeah. The stuff they're talking about is so simple. It's just taking advantage of the fact that, it's like saying, well, used to cars didn't have keys, so you could just get in a T model and drive away, I guess. I mean, but they didn't have keys for these systems.
Is that also when you were in college?
Yes, it was. Actually, I was before that. We rode a buggy down to the mainframe center and had to tie that up outside. Often gunfights at noon.
On that topic, if I want to chime in, I was one of those students that got hired because
damn you.
One of my projects when I was in college that I didn't. I was finishing a degree here in the United States, and one of my projects that I started towards the end was an online multiplayer game, and it turns out that the systems department at the university had a Next. Does anybody remember the Next?
Yeah, that was
Yes.
Steve Jobs' company he founded after Apple was BSD based, right?
Yep.
The next
Exactly.
Cube, right?
And this thing was actually relegated to the corner and nobody was using it. So I said, well, can I have access, please, sir? And I started running a MUD on that, which is the multi-user dungeon. And before you knew it, I was running user counts on that MUD that were 40 and 50 users playing multi-user dungeon all the time. And I was actually starting to push the limits of the internet bandwidth at that time, which was something miserable. It was like a T1 or some bullshit. We're talking 1990, I don't know, 1993, 4, somewhere in that period. And I was running a fucking huge multi-user dungeon, and like all the systems guys at the university loved it. They're like, let's hire that guy when he's done doing this.
These kids today and their fancy T1s. We had a T-1 when I was working on it. It was like,
Good Lord.
So yeah, I was the quintessential heretic at the time because I was hacking around with the Next, and it was cool.
All right, let's go, Lee, comments
Yeah, so I was
on...
going to say, Doug, did you have a formal job description? Or were you making it up as you went along because you were solving problems?
there was a title called sysop, because of system operator, and
it wasn't even system administrator then. It was
no, it was
system
called.
operator,
Well, and
yeah.
I mean, I was a student, so I mean, I worked at mainframe center, and I had a job called sysop, and I was PDP-11 sysop because when I
feel
was
like back then the operator was a very common term. 'cause
well, the
even-
operator was root. I mean, sysop was meta user king, and I got that job because when I was in high school, I worked for a company that was they had dial-up mainframe access for their processing, and I learned all this PDP-11 stuff. And when I went to school, they were like, I went down there, was like, can I get a job? And they were like, do you know anything about PDP-11? And I was like, I'm there. And they were like, well, you're the new sysop. You're in charge. Have a nice day. And just keep it running. And if anything goes down, you're at fault. So, just keep that in mind. And then you got to learn all this great stuff because...
And this wasn't in Rhode Island, right?
No.
You didn't grow up in Rhode Island.
No, it was in Tennessee.
Tennessee, that's
And-
right. Okay.
And you got to learn about professors and
Yep.
professors. But we had the little frosted glass window like in a doctor's office, and people would bang on it, and the professor would go, why have my security job or my statistical jobs not been processed? And it's like, well, let me explain. Do you know what a sunspot is? Okay. Sunspots emit this thing called a Z-wave magnetic interference, and that magnetic interference comes down and it affects the platters because, see, the platters are horizontal, so they catch a lot of magnetic interference from the sunspots.
Was it a physics professor that could totally
you better
show you
damn
up,
well
right?
hope- No, they were like business professors. They don't know what the hell you're talking about. They go, really? And they don't know anything about computing. The physics professors didn't know anything about computers. They're just like, really? How do we stop that from happening? Well, first thing you have to do is you got to put tinfoil all over the top of your terminal. That will help. Probably won't fix it, but it will certainly help. So why don't you go do that, and let's see if it improves. And then it's like, I hate that guy. He's got job priority 99. I got a B in his class. Yeah, we'll fix that right up.
So Doug was literally the sysop from hell.
I was.
which
I was the bastard operator from hell. I mean, I swear that guy stole half that stuff from. I mean, he didn't, but I mean, everybody was doing that kind of thing because nobody knew what the hell was going on. People would come down and knock on the glass, and they'd be like, "Is my job finished printing?" No. You see, the printer, it has to print each letter very slowly using a small nib, and it makes each one of those little dots you see on the green bar, and that takes a long time, like days, maybe months. But someday
you really did say all this stuff too. That's the hilarious part, because I can totally picture you
and
as
I can
a
say it
college
with a
kid
straight face
behind the safety of the glass window.
Right.
Going, I'm totally gonna mess with this.
You got that PhD student. You got the PhD student from astronomy who finally got to use the computer, and you get to mess with them like that. Like you may think you know something because you've been looking at stuff up in the sky, but you don't know nothing, buddy. You see all those pipes? Yeah, you know what's running in those pipes? Radioactive freon. Radioactive. It's radio and active at the same time. And if that stuff leaks because you send too much crap down here, we all die. You too. And I wouldn't touch those reports because there was a problem earlier. But go ahead.
That was Doug Sisup.
He was a Sisup from hell, man. I swear to God.
That's awesome.
Wow. Such an asshole, and I love it.
It was fun. We had our little glass.
I want to talk about the future, but talking about the past has been pretty entertaining so far.
I tell you what,
right?
We lived in a hole in the middle of the road, and you had to duck when cars. Yeah.
Oh boy.
Sorry, I'll steal Monty Python.
I did like. I have to admit, I did like VAX VMS. I think it was a solid
awesome
operating system.
It is.
It was still around until not too. There was Open VMS, and that continued for a long time. I used to know one of the main contributors to VMS.
Yeah, I mean
it's a Danish guy. He was awesome
until that. VAX just finally kind of went away, and
yeah. Well, then it was Open VMS.
Yeah, I mean they had Open VMS for a long time, and people still ran it on certain platforms. Plus, there was a lot of those platforms out there, and if they quit supporting it, you had to run something. But there were people that knew VMS, so they just ran it.
I tell you what, at the time that I was looking at Open VMS, there was still a lot of Windows 95. And when I learned about VMS, I was like, wow, that is a far superior operating system to what we have today in the Windows world.
DEC was so far ahead of its time.
The tragic irony is that the core of the Windows NT kernel
was came from VMS.
Came from a digital equipment and Microsoft project. Which is I think that's terrible. The other tragic irony that I should mention, and it's just kind of a quick shout out. The first mainframe guy I encountered when I was a student ended up being a person I worked with. Really great gentleman, kind of a sysop from hell as well. But unfortunately passed away fairly recently, so I had to go to his service. But I really kind of miss those days.
So let's stay in the past since we're on this topic.
I guess
I have a question. We are sticking to the questions, right? We talked about how Doug and Joff got their start in information security, which took us in the past. What were the most challenging parts of your security career back in the day?
Me?
Anyone?
I think mine was the same as it is today. It was convincing people that security is something that you have to have, and that it's not just an expense that doesn't result in anything. It's really tough to sell organizations on that, and in the past it was almost impossible to sell them on it. And then today, only when they start getting attacked and only when they start suffering do they then start going, why don't we have more security? And, so I honestly, I would say that in the past it was that, and in today it is the same. It's the same. It's a little easier.
We've come a long way.
We've come a long way. Today there's products you can show them with fancy flyers, which helps. But there's also...
But I think there's certain industries and sub-industries that we no longer have to spend a lot of effort convincing that they need security. I feel like the financial industry...
That has improved vastly because they see the results of problems. They know that people get hacked. They read about it, and it's a lot easier to sell somebody on it, but they still
But that's still not a majority, I would say, because you go to a lot of small businesses especially, and it's still a lot of convincing. Joff, Lee, comments on what was most challenging for you in the past?
So mine, just to take it back to the academic world for a minute, was the operational imperative. The academic folks, especially the folks who were dealing with large statistical data sets, they really wanted network performance. I mean, they were driving, gigabit Ethernet really early because they wanted to get that data moved across the network. Yep. And so anything that we deployed from a security operational perspective, if that got in the way of performance, that was immediately the enemy. So as you might imagine, the early firewalls and the early IDS and IPS, or I should say IPS systems, had the effect of doing things like reordering some TCP frames and perhaps dropping a frame or two because of their inspection. And that pissed a bunch of faculty people off. I mean, it just pissed them off flat out. And they're like, hey, don't get in my way. And invariably, the directive came down to favor the operational environment versus the information security environment.
I'd say for me, I think it was, now that we think back to some of the earlier days, was convincing people that security was a thing that needed its own group and its own funding and its own processes, its own mission, and defining how we interacted with all those other groups. And I still think, to bring that to today, that while most organizations recognize a security division or group within the organization, I think the thing that's still challenging is how we interact with all of those other groups. It's greatly improved over time. I still think there's a lot of work to do there. Yeah. It's still a challenge today. Most of the challenges I hear from our listeners and those in the community are, and usually like when they're talking to me and they're a fan of the show, they're like, I hear you guys talking about X, Y, and Z, and like I'm still trying to get my company to buy into like A and maybe B. Never mind, some of the things that I heard, you or your guest talk about on the show. So I still really truly believe that convincing people that what they need to do with security and interacting with other groups in that capacity is challenging.
Paul, you actually just really reinforced what I just said, right? The Phoenix Project. Mm-hmm. The idea is security does not need to be a shop that says no. Security needs to be a complement that is aligned with business. And if we cannot make that argument, then we will never actually win the political and subsequently the budget battle. You've got to be able to make that argument to say we are aligned with the business. We are enabling the business by mitigating risk. And if we can't do that, then we're never going to get the resources we need.
It's true.
No, it is.
I think some will say, it's, to a certain extent, I agree, other than when there's definitive proof of gross negligence, that when a company's breached, one of the first things that an organization will do is just fire the CISO. Like, that's a good public relations move. Like, just do that. I'm like, no, now there's someone with really valuable experience, because you learn more from your failures than you do from your success. Like, that person should continue to be a champ. Maybe not in every case.
That's somebody asked me on the phone, not just like last week. A guy called me, and it was a C-level. He said, "Should we fire the CISO because we had this problem?" And I was like, "Why would you do that?"
Why would you do that?
I said, "Did the CISO do something wrong?" And they were like, "Well, we got had a problem." And I'm like, "Yeah, but why did you have the problem? Was it because that person willfully didn't secure something, or was it because they came in and said, 'Can we have this budget?' and they said no? So maybe you need to fire whoever said no to the budget." And he was like, "Oh, well, thank you."
And I'm all for total ownership and all that stuff too, but at the same time, usually when the victim of the ransomware attack or social engineering, usually that person doesn't get fired, right? Yep. And I there's been some debate about what punishment, and I don't agree with a lot of the processes in terms of punishment around that. You wouldn't necessarily hold that person reliable. Now, one could say the CISO does have responsibility for security in the organization, but there's so many things that go into that, right? And so many things that are beyond control. You want a CISO there to help you recover from the breach, learn from it, and move forward.
I mean, right? if the CISO made every effort to put good policy in place, and it, you wouldn't budget or it didn't work. I mean, you don't fire the COO when somebody backs a forklift over somebody. It's
good analogy.
You go down there and you say, did this guy back the forklift over him because he was drunk, or did he back the forklift over him because we have a lack of policy, or what? And you have to look into it. And they would never even think about that, about going down there and firing the guy who got run over, or firing the COO because somebody backed a forklift over somebody. But when, security events
I will say that a CISO always needs to have a prioritized shopping list in their back pocket.
Yep.
Because inevitably, when the political battles fail and they do, some disaster will happen.
Yeah.
And when that disaster happens, a C-level person is going to come to the CISO and say, if they don't fire them, they're going to come to the CISO and say, what do you need? And you should rip that list out of your back pocket and say, here it is.
I agree.
But that doesn't necessarily have to be a shopping list. I disagree with the shopping list. That needs to be a list of initiatives that might be supported by technology purposes, but that needs to be a very targeted list.
That's what I mean. It all comes down to money anyway. So, I was just shortcutting the middle part.
Have it tattooed on the palms of your hands.
Okay, that's a little extreme. Sorry, Lee, you had a comment.
So I was going to say, one of the things we're dancing around is the what level of implementation is going to work. We all know there's no such thing as absolute security, but there are those out there that you say, we put in this, and they'll think that's the absolute panacea, then nothing else will go wrong ever. So I find there's that education piece in working with them, because they, you don't have an infinite budget unless you're in .gov, and even then.
No, you should never talk in absolutes. Lee's exactly right. If you talk in absolutes, you're being foolish, right? It's always an incremental scale. It's always, we're going to get this much better. There is no perfect solution, right? Even though C-level folks are going to say, I want you to stop this. I want the perfect solution, right? There isn't one.
No, I was sitting at a board table once, and I was being the advisor to the C-level people about these marketing presentations, and in between them, the CEO said, "This will fix it all, right? I mean, it's going to work after that, and we're not going to have this problem again." And I'm like, "No, that's not how this works. This is just reducing risk. You're mitigating. You're not eliminating. You're mitigating." And he was like, "Well, what will it take to eliminate?" And I was like, "Well, how much money you got?" And even then, it won't work.
Right. We're going to encase all the computers in concrete, and they will be fine.
Quit using computers. Back to the heliograph.
Cut the wire. Go back to a mainframe. We'll just have everything.
And I have to prevent myself from saying, if only we still had the mainframe. But
well, we still do have mainframes. They're still in use today. They haven't gone away.
Just have to get rid of that internet component. That's what causes all your grief.
Yeah. Well, you don't need communication. Screw that.
You know what, though? Even if we don't have the internet, you're still going to get hacked.
Well, yeah, you got hacked on the old mainframe. We didn't have the internet when I was a sysop.
Right. Does the mainframe have USB ports? Do the ones today have USB ports?
Oh, yeah. Ones did. Well, they probably. I don't know. I haven't seen one. Surely they do.
I don't know why I just thought of that really bizarre question.
I'm sure, but J-series and stuff for IBM does. I don't know. I mean, that's the only thing I've seen, but I haven't. I don't know.
Next time you're in a data center,
I know.
Just be like, hey, can I check your mainframe for USB ports?
Crawl around back there and be like, yeah, it's a 360, 370. It's been in operation since 1967.
I don't think that model has USB ports stuck.
That model does not have USB ports. But IBM may have made them by now, so you could buy a big bolt-on chassis.
Wow.
It's like a giant...
I tried that line on a good-looking girl. I said, can I check your mainframe? And she's like, fuck off.
You have to have hardwired terminals?
Good Lord. Wow. All right, where are we going next?
The history of mainframes.
The history of mainframes. We're still stuck in the past. This has been like the history of computing.
It's not my fault. You asked.
All right, so let's stay on that topic because it's our show. We can do whatever, talk about whatever we want. I am looking because I reference things and I get strange looks from younger folk when I talk about Unix, and I'm like, well,
Unix wasn't what I thought he said he was going to say.
Unix was in Unix. People are like, you mean the people that castrate themselves? I'm like, no, like Unix, and I'm like, the operating system. They're like, oh no, you spelled that wrong. Isn't it Linux? I'm like, no, Linux is a kernel, and they're like, what do you mean? I'm like, well, there's the whole GNU utilities, and then Linux was just a kernel, but all the other things came from this whole genealogy of Unix. And they're like, do they submit a sample to Ancestry.com?
Oh, my God.
No, not the people that don't have genitalia.
But there is a chart.
You know what I'm so amused by? I'm so amused by the fact that Paul is actually detecting a little generational difference here.
Yeah, that's how old I am now, Joff. I am. I'm at the point
which is really, for us old fucks, really amusing. Right?
Because I am the youngest person on the show right now.
Yeah, you are.
Probably
now.
by 10 years or more. Just saying. Just throwing that out there. But, so,
God, that's
but
cold,
hold
man.
on. Let's get back.
See what rap music caused?
Yeah.
Smartassery. That's what it caused.
I'm full of that.
Get off my porch.
So, but the whole going back to Unix and understanding where everything came from, it's one of the things that I'm including in my now keynote presentation that I'll be giving this year. And I think that we need to learn from the past, and what a better way to learn than understanding where things came from in the Unix and in Linux world. And just in Linux, it's just like if you look at the genealogy, I mean, Linus is a smart guy, came up with a friggin' awesome kernel. Obviously, we still use it today, but so much of the history behind the commands that you're typing inside of Linux today has a history that goes far back beyond Linux. And I mean, I'm excited in a way that Linux is a common term and understanding in most people that do computers today, and even some outside of that. I think that's really great, right? And that certainly wasn't the case 20 years ago by a long stretch, right? But so now that Linux is common vocabulary, you talk to people and they're like, they don't understand anything that, like, how we got here, where we came from starting with PDP 11 was actually where the first, in the charts that I've seen, is where it first came from.
Yeah, that was all that.
That's where everything was based on.
And I mean, Linus did a great thing, but he didn't invent it. And I mean, he would never tell you that he did. I mean, he basically re-engineered something that was there.
So here's the thing, and I'm glad you mentioned re-engineer. So speaking of rap music, right? Music in general, and this is one area that I didn't get into a lot of detail in my DerbyCon talk, but in my upcoming keynotes I'll be talking about quite a bit. And it was Kevin Finisterre that challenged me and said, there's this thing in music, it's called the amen break. And I'm like, what is that? He's like, go research it, it ties into your talk. And he's like, and then tell me what your security amen break is. And I'm like, okay. So I researched the amen break. It's like some little known blues / jazz musician that released an album. On the B side of that album, there's only one song on each side. That's all that could fit back then, right? On the B side of this album is where they sampled the amen break. It's the most famous sample in music history, the most sampled clip in music history. It's in over 1,500 songs today. And the sampling crosses genres, rap music, all the popular music, I mean, you name it, rock music. I mean, it's been sampled. There's actually a GoFundMe to get the person more money for his, because it was sampled so much.
Wow.
And so then I got started thinking about Kevin's question of, well, what is the amen break in computer security? And I really came down to the variants of Unix and BSD and Linux and open source. We've got lots of amen breaks that we sample from to create great, even Linux, as you said, and other variants of Unix or BSD have sampled from the past. I mean, so to put it at the top was PDP 11. What was was that the operating system that they developed for?
I don't remember what it was.
What was that? I don't remember what it was.
What it was called.
That would be the amen break, right?
Yeah.
It's the thing from which
that's
all
the
things
thing.
are
Everything's being
derived.
sampled out of that. And
Right.
I mean, partially because it was available. And I mean,
and then there were several other amen breaks that came after it, right?
Yeah,
Like,
absolutely.
when we look at the shells and
Well,
bash, and we look at the system D, which we talked about, I think, last week, and all of these different concepts that, quite frankly, today is a source of a lot of frustration, as the Linux distributions change things over and over and over again. And we're like, this worked in like 1975 all the way through 2005. There were no major engineering issues with certain technologies in the realm of technology that we're talking about, yet people just seem to want to change them. But anyway.
Yeah, I agree.
My question to you, though, is
I remember-
is the operating system reached the point where it is no longer relevant? I mean, if you look in the world of application containerization, and we see effectively what is segmentation at the app layer, which is way above the OS, does the operating system actually matter anymore?
That's an interesting question.
It's the concepts from those operating systems still matter, because you still at some point have the operating system underneath, and we can't forget about it completely because there's still security things that have to be done.
I think it's security we can't forget about. I think the level of abstraction has, for most users, has reached a point where that it's almost irrelevant at
I don't know
point.
if user-wise, but developer-wise, Joff, I agree with what you're saying, right? I think less and less the developer has to have an understanding of the application, especially when we talk about serverless and containers.
Well, I think it leads into the question of, should we redesign the stack? Is the operating system so irrelevant that it needs to be customized exclusively to support containerization these days? Maybe it's not the right model anymore.
Lee, sorry, go ahead.
I was going to say, I'm not sure if we're all the way there yet, but we are fast tracking to where what's happening at the OS level doesn't matter very much, because all I can care about is my containers working, which is great. You can secure the snot out of that layer and the hypervisor, but then you're still going to do battle at the container level as to how secure it is or not.
Yeah,
that makes sense. There's a lot of truth to that, right? And you know, there are other things. There's some outdated concepts. A memory page size in an operating system is still basically pegged at 4,096 bytes, right?
Yeah.
Yes.
That's a very small number, right?
Yeah.
It's a very small number considering our resources today. And you know, some of the algorithms that have been around forever in terms of paging, swapping, memory management, and so forth, date back 20, 25, 30 years, right? And so the question, it's an open question I'm posing. Maybe we need to redesign the stack. Maybe we're at a point where the stack is no longer sufficient to support the areas which we're venturing into.
Well, I think it's going to be a small number of people that have to actually pay attention to the underlying OS and infrastructure, whereas everyone else is going to build on top of that. And largely that's because bandwidth and CPU and memory and system resources are so much more plentiful than they were back then. If you were a developer 20 plus years ago, you had to really care about the environment that your code was running in. You had to know the operating system. You know, when you were programming in C, like, you had to know the operating system, know its limitations, and code very efficiently with that knowledge in mind of operating system concepts. When we get into languages today, again, I think the developers are going to be the first ones to go, I don't know, I know the application really well inside out and backwards. Someone else is handling all of the infrastructure because it's so abstracted from developers today. As security people, we still have to care about everything.
The other thing, I'll just see what Joff has to say about this, though, was one of the things I think limits that idea, I don't disagree with you, but one of the things I think limits it is just that backwards compatibility problem. You know, like you say, it's been 4,096 in a memory page for so long. You start tweaking that stuff, all of a sudden it's like, you know, oh, we're going to have to stop using all this stuff and everything's going to have to be recompiled. So I think sometimes that limits people's willingness to even hear about things like that, because they start going, okay, everything that came before it is gone, and now we have to start all over again. We have to learn new techniques. So I don't disagree with you. I just think that that's one of the other factors that people have out there going, I don't know if we want to go down that road, because we have to get customers. It's the OS2 problem. Remember OS2?
I do very well. I was in OS2. Well, this is like Security Weekly in the past, like historical episode. I was an OS2, many of our listeners know, administrator. That was one of my first
I had a copy of it when it came out. I called IBM and I said, can I get this? And they said yes, and they sent it to me. There's a giant stack of disks. And
floppy disks,
and I tried to put it on like 3 different machines, and it wouldn't run on any of them. And they
Welcome to my world as the first job as systems administrator.
And I'd read all this stuff about OS2, and I said, this is such a great thing. It's redesigning the stack. It's just start from zero and build something brand new. And it wouldn't run. I never got it to run on anything because I didn't have enough hardware to run it. And it was this thing like, well, I need ECC memory to run this. And I'm like, wow, that's expensive. And there were all these restrictions that you had to have. In fact, the first time I talked to IBM Tech, they told me I not only had to have ECC memory, I had to have matched chips. So I had to have chips that were from the same production lot, and that you could order those. And I called someplace and asked about it, and they were like, "Oh yeah, they're like $8,000 a piece, and they come in a gold-plated box." And I never had it. So I
think the OS2 Warp version.
Well, yeah, later.
When it became Warp, I think.
Well, they fixed it. They actually fixed OS2, and they got it run on like
in the most recent version. I tell you what, in my assessment at the time, this is in like 1990. 7. That's how old I am, and it was far superior to whatever Microsoft was offering at the time.
Yeah, it was all the specs on it were awesome, and it sounded great. And I was like, I'm going to try it.
Documentation wise, I would always like get an error, and it would give me a code, and I'd look up that code, or I would get an error, and it said, research this error, and I would research that error and say, please contact your systems administrator. Error number something different number. Then you go research that, and it says you should contact your systems. I am the systems administrator. God damn it.
Yeah. No, we've all been there.
Yeah.
But yeah, I mean, I think that's a good example, though, of somebody trying to start from ground zero. And
it had like a PS exec type functionality in OS2 Warp.
So it
I don't remember what it was, but
great product, but it just never was. You couldn't get people to adopt it, and it meant giving up everything you had and starting over. And
well, it's a very good illustration of how legacy of developed products affects the forward progress, right? And Microsoft learned this, the hard way almost, right? But they learned it well, and they're like, we have to do backward compatibility. They got that message. And guess what? The entire security industry, I would actually go out on a limb and say, is pretty much born out of the need to do backward compatibility, right? Because we all take advantage of the fact that, companies, deployments, etc., need this backward compatibility thing. We could always say, hey, go ahead, get on the latest thing. You'll be great. But then the customer would come back and say, what do you mean? You mean like 90% of my shit's not going to work? I'm like, yeah, upgrade. It's cool. Right.
So it's that same thing happened with Solaris 2.0.
Yeah.
If you remember that?
I do.
I mean, basically Solaris 2.4 was the first really usable. Some may argue 2.3. But yeah, because Sun had to go reintroduce all the compatibility libraries.
I'd go with 2.4.
Well, when IBM started selling AS400s, one of the main tenets of AS400 and OS400 was this will always work.
Oh, and AS400 is not a mainframe.
No, it's not. It's called a mini computer.
A mini computer. I couldn't think of the term. We called it mid-range, and I'm like, yeah, something like it's mini, a mini computer.
But
mini computer?
Yeah. They called it a mini computer, so it was somewhere between a mainframe and some kind of like whatever the hell a PC was.
Micro PCs is actually what
but OS400 was supposed to forever. As long as we all live, you'd always be able, if you knew how to use OS400, you'd always be able to work with it. And even if they add things to it, it's always going to keep working in the past. So you can keep those apps, because a lot of people develop proprietary applications for AS400, and they're running big manufacturing concerns off that. And one of their big problems with buying was I don't want to switch brands. I don't want to rewrite all this code. I don't want to rewrite all our proprietary software. And so IBM was saying, look, it's always going to be cool. You'll always be fine. I mean, we may add new features, and you can use them if you want to, but you don't have to.
And those things would run forever.
They still running. Yeah. You go out there and find them right now. I bet you go in a manufacturing shop somewhere if you could find one.
There's an AS400
you'll see
somewhere.
An AS400 sitting on a grimy shelf somewhere covered in like metal shavings, and it'll still be sitting there churning along with
older than most of the people who are your students,
milking machine cables attached to it, and it'll still be happy and running along, and nobody even knows what it's called. And now it's called J Series, but
is that what it's called?
Yeah, they changed the name of it.
Yeah,
it's called J Series.
Who remembers OSF1?
Cool.
Yay!
What was OSF1?
It was sort of the bastard child of VMS and Unix to run on an Alpha chip.
Yeah.
Oh, I remember that. Yeah.
Wow. I think we all try to forget that.
Yay!
Oh yeah.
Most people don't even. When we say Alpha, a lot of people probably that was a different chip architecture, right? Like Intel, ARM, MIPS, and
RISC based.
It was a RISC-based Alpha chip that was specific to DEC.
Was it VAX? It was on VAX.
It was digital equipment.
I mean, it was the VAX, but those boxes, I have one.
The consolidation that's occurred in that market alone, right?
Weighs about 300 pounds.
Intel fought like hell to dominate that market, but for a while there was a lot of diversity in the processor market. Sun was in the game, DEC was in the game, right? AMD is still in the game. There was a lot of stuff going on. Motorola was there, and for the mainstream computing device, Intel won. But that consolidation may not necessarily have been a positive development for the market. I mean, having that diversity was good. And it also reminds me of the fact that I think from the security industry perspective, as time goes on, your memes are killing me. As times go on, we have seen security risk migrate up the OSI stack, right? We've seen it in the infrastructure level. We've seen it layer 2, layer 3, and we see it at the operating system level, right? And then it starts going even further, right? It's going up into the application layer and beyond. And so as things mature, there's this definite trend of risks and vulnerabilities migrating up the stack as well, along with the technology. That's it. That's all I got to say.
Lee was just about to say something.
Yeah, I was just going to say that sort of also has drive some of the specialization. I mean, when I started in '89, my first firewall, I was the network guy and the system admin and et cetera, et cetera. And you wouldn't combine those things today because of the complexity and intricacies of getting the security right and the performance right to get the mission done. I think when I was somewhere in around 96 or 7, I convinced management that we needed a separate team with a separate skill set for the application layer on the box for web applications, which we're growing. I think what I'm leading up to. I think as we continue down, we may see yet another layer of specialization as we continue this path to change the layers up, for lack of the right term.
I don't know where I was going from here. Now I forgot.
We totally fucked him up.
I was going to go to the next segment. That's what I was going to do because we're up on time.
There's always that.
That's a great idea.
How about that? All right, with that, we'll take a short break, come back with the security news for this week. Stay tuned. Don't go anywhere.
Thinkst Canary makes high-fidelity honeypots that set up in minutes and requires no ongoing administration. Attackers moving silently on your network advertise their presence by tripping over them. There's a good reason Thinkst Canaries are deployed and loved by some of the best security teams in the world. They're inexpensive, they're simple, and they work. For more information, go to securityweekly.com/canary or direct message @ThinkstCanary on Twitter for more information. Domain tools help security analysts turn threat data into threat intelligence. They take indicators from your network, including domains and IP addresses, and connect them with nearly every active domain on the internet. Those connections drive risk assessments, help profile attackers, guide online fraud investigations, and map cyber activity to attacker infrastructure. Fortune 1000 companies, global government agencies, and leading security solutions vendors use the Domain Tools platform as a critical ingredient in their threat investigations and proactive defenses. For more information, visit securityweekly.com/domain tools.
Welcome back, everyone, to Security Weekly. You heard the new advertisement for Thinkst Canary. If you watch the video, I know most people listen, and we're going to work that into the programming. There's some great testimonials about Thinkst Canary. They came up in the video. You can see them. There's lots of tweets from people like Jeremiah Grossman and others about Thinkst Canary. So we will work that in the future. But check out the video. It's a great little commercial snip of tweets coming in with cool people saying cool things about Thinkst Canary. In other sponsor news, securityweekly.com/ACM. Active countermeasures. You can go there. Speaking of fast Fourier transforms is something we talk about a lot in the context of active countermeasures. And if you want to see how some of those algorithms work to find backdoors in your environment and how that's all now rolled up into a nice, easy to use interface, you can visit securityweekly.com/ACM. All right. I think that's all did I do my due diligence? I think I did. Now we can talk about stuff like the security news. It's interesting. This story is first. I guess we'll lead into it, which is going to lead to more of a discussion. But hey, there wasn't too much. I mean, Cisco had some flaws, PHP pair and stuff like that. But I found an article, and the backstory is some of the listeners might have shared what happened with my furnace and my HVAC system at home. I'm like slowly becoming like this HVAC. Like I'm really just at this point, I've had so many problems that I'm asking the people that come out to try and service the stuff. I'm like, so how did you learn this stuff? Is there like a course? Because I'm just going to take one and avoid calling you people altogether. Because that's how many problems. I had so many problems with my old system, I put a new system in. Now, a lot of those problems relate to this article, and I think it relates to security in that I did stupid things, and not knowing that I needed to do other important maintenance things caused a lot of failures that ultimately led to getting a new system. But it also is very similar, I think, to security. So this article is like 51 things. That sounds like a lot that most homeowners aren't doing but need to. And I'm like, yeah, a lot of these, like either I've done or I've dealt with the consequences of not doing that particular maintenance on your home. And I feel like we suffer from the similar things, but just in our networks and systems. Yeah. There's probably more than 51 things. Like we could write an article of 51 things
you should be doing on your
sysadmins or network people, don't do, but need to be doing, in terms of regular maintenance to avoid, to have better performance, integrity, and more security moving forward.
But it's just like doing this stuff at your house. You
don't do it.
But it's because you're doing something else.
Yes.
Because you come home and you find out, oh, there was a fire in the garage. I need to clean that up. And then you don't get around to cleaning the dryer vent. And same thing in your network. You go in and somebody says, oh, the email is down. And you
show of hands, how many people have proactively cleaned their faucet aerators? Proactively. No, proactively? No, it's clogged and you go in and clean it.
Well, yeah, okay.
Okay, yeah. Not proactively, though.
You mean just like for fun?
Like before it gets clogged, knowing it's been a while since you've cleaned the faucet aerators, you're going in.
Like when I get home tonight, I could sit in my office and have a cigar and watch
my faucet
Netflix.
aetrators should probably be cleaned before it disrupts.
Warning.
It's going to disrupt water flow, Doug. You got to get in there with the toothbrush and scrub them.
That's my parents. My parents would do that.
Yeah,
my dad would have a chart.
Yes,
and he would have it on a clipboard, and it would say faucet aerator, and he would do it when it came up on the chart. Yeah.
I think we need similar hygiene,
I do
you
too.
can call it, for your network and systems, right?
And you have to convince the upper management people to buy into that, because that's the hard thing to do, because they want you to keep the lights on. They don't worry about the faucet aerators until the faucets stop working.
They're worried about you doing new things. So in my case, upper management is my wife, right? And she's like, we want to put an addition on the house, or we want to install an entirely new shelving system. And I'm like, well, we really need to clean our faucet aerators before they get clogged. Like, that shit gets thrown out, dude. They're like, no, we want new features. We want progress. I want the room to look completely different from the way it looked yesterday, because that makes everyone happy.
Let's replace the whole sink.
That has happened.
No, that has happened
More than once.
That's how I learned about it.
Yes.
I didn't even know about faucet aerators, and my faucet stopped working. I was like, this thing's fried. And I called like a plumber, and they brought a new sink, and he was like, you can just take this little thing off and clean it out with a toothbrush, and it'll be fine. And I was like, no, I wanted a new sink.
We wanted a new sink.
Yeah, no, I knew I could do that. In fact, I have a whole cleaning apparatus out there in my garage. I was ready to do it. I built a machine to do that for me. It's like a artificially intelligent faucet aerator cleaner.
Right.
And
I did this one recently, but only because there was a problem. And I feel like we do this in security too, right? We get breached, or there's some major security event, and then we go, oh, crap, we should really do this kind of maintenance or this other thing and monitor this thing in the future and take an action and have a process for it. But that usually only happens after some event.
It's reactive.
Cleaning my dishwasher, same damn thing. It's reactive. I'm like, I know years ago I cleaned out my dishwasher, cut myself on a piece of glass, because everything that goes in the dishwasher, it gets broken, it gets dirty, things fall out, straws, whatever. It all goes in the bottom of your dishwasher. There's a grinder in the bottom of your dishwasher that grinds that stuff up so it can more easily drain out. However, it's really hard to grind plastic straws and glass and things like that. So
you just got to keep on trying.
All of a sudden, your dishwasher's making weird noises, or it's clogged, and you're like, time for a new dishwasher.
There you go.
And then I'm like, hold on, wait a minute. I think I read something somewhere that said you can clean the dishwasher, and if you're like me, you go to YouTube and you figure out how to take apart your dishwasher. I did that years ago.
Then you buy a new dishwasher.
Yeah. Then when you can't get it back together, you have to go. I actually fortunately got it back together, but then I was like, we should probably do that regularly. And then every weekend, my wife would be like, well, I really want a new shelving unit and hang a new mirror here and all that stuff. And then one night our dishwasher's making a heinous noise, and the next morning I take it apart, and lo and behold, there's this gigantic plastic straw that was stuck right in the grinder, so it was making like a noise every time the dishwasher turned on, right? And so I cleaned it out. Now, the first time I did it, I just shoved my hand in there, and I was like, I had to pull this shit out, and I cut my hand wide open on a piece of glass.
Yeah,
because glass turns out it's really hard to see.
Yeah.
So when I did it this time, I was like, ooh, pliers, tweezers. Yes, I'm going to pull everything out of there. But the point is, I didn't do it until there was a problem.
Why would you do
and
that?
I think that we talk about we're talking earlier in Enterprise Security Week about the integration of operations and development with security. We need to have regular tasks that also speak to security and not wait until there's a problem. This article just reminded me of that, and reminded me that I
need to clean your oven doors.
Clean my oven doors.
Well,
yes.
The thing that popped into my head when you started talking about this is, like when you get a new computer, do you start with the OS and add just what you need, or you bulk drop everything from your old system, including the crap you don't use and the old shit that's hiding in the corners? Which approach do you use? And then in a business, do you have the time to rebuild only what needs to be there? But it's an important hygiene step.
Yeah, and technology is making that easier. Like with containers, it's much easier to do that. I don't know about easier. It allows you to do that and continue it moving forward. Getting there is still some work, but I think a lot of security comes down to this regular maintenance and hygiene that we're talking about. And certainly the parallels in this article were unprecedented, especially since I do have a brand new HVAC unit and it is failing, and nobody can figure out why, which is interesting.
There are a couple IT Easter eggs hidden in there too. It's a fairly comprehensive list.
It is. Anyway, I thought it was a pretty cool article.
Okay, this says cleaning weep holes
in your windows. You don't clean the weep holes in your windows?
No, I don't even know what the hell it is.
When water gets like inside your windows, like if you have it open and it goes in the window sill, if it didn't have holes that are called the weep holes, that water would just collect and pool
I just board the windows up and put plastic over them.
Well, you could do that, or you could just clean your weep holes if you had water that was inside of your.
I learned.
hate it.
I learned you were
weep
supposed to
hole.
leave your weep hole alone a long time ago.
No, it's got to be. You got to have a clean weep hole. That's what I'm saying. Anyway.
Oh, there's good stuff on here. Everybody should look at this
is.
article.
Yeah, I especially
You
new
can learn
homeowners.
something. Yeah.
I'm putting together my advanced homeowner kit, and it includes a device to measure the CFMs in your air registers,
And bourbon.
wind speed, velocity. There's something in there about
my
a swallow,
God.
but it does measure wind speed, velocity, and all I can think of every time I say wind speed, velocity is Monty Python in the search.
Now they
book.
got a misspelled word here because I've always wanted to remove garage grim.
Grim.
It says removing garage grim.
Yes, the
And
the
they
grim
left off
reaper
the
that's
E-
in your
E is
garage
invisible.
should be removed.
Yeah.
I think they meant grime.
Is
But
there grim in your weep hole?
That's the
What was I
invisible
saying?
E. It's a
That's
thing.
the name of this episode. Grim in your weep
Visible E.
hole.
Grim in your weep hole.
I knew
I
I
think it's
probably
that
should have
they're
saved this story for last because it's going to be really difficult to transition off of the story and on to something else when it has
And
terms
now for
like
something completely different.
grim and weep holes and,
Grim weep holes.
and blowing out your soffits. It does.
And now
say-
for something completely the same.
Ooh, yeah.
blow out your soffits after you get rid of your grim weep
Weep
holes.
holes.
Weep holes.
$1 million idea, Paul. Class, hunter-gatherer skills for IT professionals.
Yes.
How to survive in the real world.
There you
It's
go.
true. It's true. Anyway, where do we want to go from here?
Oh, how about I like the Nest missile alert.
Yeah. So someone threatened a family using a Nest camera to broadcast a fake missile attack.
Yeah.
I'm not sure how do you really like, how do you do that?
I don't know. I mean, I wasn't sure exactly what they did or how the alert was presented.
Yeah.
I mean, it was like a Nest camera, so we all have this stuff. And I was looking at mine, and I was like, I don't know how this camera would, broadcast an alert to me. I was like, maybe the guy walked up on their front porch with a little sign that said "missile alert incoming" or something. I don't know. I thought it was really strange.
It's interesting. They said they compromised the Nest devices through exposed breaches in other websites.
Well, I get the hack. I just didn't understand exactly what happened.
With Ring, it sends you alerts when other events happen.
Yeah, I guess
and actually
so,
they came
yeah.
under scrutiny for who has access to the
Right.
footage on your Ring, but it will send you alerts like a suspicious car was
Right. Yeah, I
in
get it.
there.
I
So
get
I could
those,
see
yeah.
changing one of those alerts and going,
Yeah.
there's a missile attack.
Yeah.
I don't know if that's available on the cams
Well, that's what I was wondering.
from
because-
Nest, because Ring and Nest are two different companies.
Yeah.
but
So I mean,
Nest makes
yeah.
doorbells and stuff too now.
Right. No, I know.
They used to just make thermostats, and they got bought by Google,
Yep.
and it's
But
becoming
my
their smart
Ring
home.
sends me alerts, so yeah,
Mhm.
somebody could hack that, push an alert out. But I mean, honestly, if I got an alert from my doorbell that said North Korean
There's a
missiles
missile.
inbound, I probably wouldn't even jump up from my desk and go clean my weep holes or anything. I would probably just sit there and go, "What the hell?"
You would ignore it and go clean your weep holes.
Yeah, probably so. Because
You would
missiles-
immediately pay attention to that weep hole maintenance that you were lax on. I know you
It's
would.
a major
I feel it.
cause of Nest attacks. Weep holes. Yeah.
I mean, one of the creepy cool things Nest is doing is they're looking for users that are using compromised passwords that have been published. It's not going to be perfect, and it feels a little creepy that they're checking for using compromised credentials, but they're trying to keep their users,
Mm-hmm.
a little more secure, and they make them change their passwords when they discover it.
I
And
think
believe
that's
the-
smartly. I mean, it is kind of creepy, but
It's cool.
yeah. I mean, hopefully they're just comparing hashes and not.
Yeah.
You know what I
Right.
mean?
Yeah.
Oh yeah,
Right.
let's not get next level creepy yet. Just comparing hashes or something.
Right.
And they do have two-factor authentication for their app, for the app itself, available. It's buried down in the options where it's hard to
Sure.
see, but you can actually turn on when you're logging into your account, whether it's through their mobile app or through the website, that you have to two-factor. I believe it's just using SMS, but still, nice plus to have.
I
So
think
somebody
that
had to work for this one.
it's a good reminder that everything you put on the internet is potentially public, and most likely someone else has seen it. That includes your password, as we're talking about in this, because your
Yeah.
password is essentially on the internet, And Twitter now has warned that private tweets were public for years. I'm not sure of the, so anyone updated the email address linked to their account between November 2014 and January 2019 could have had messages exposed.
Yep. I mean, my philosophy's always been don't say anything on the internet. I don't care if you think it's a private group, a public group, a secret group.
But here's the thing with Twitter, they've always called it a direct message.
Yeah.
They haven't called it a secure direct message. They haven't called it a private message.
Right.
They've called it a direct message.
I mean,
I'm not trying to defend Twitter in this case, because you do think, well, if I send this, then the public can't read it. But it just means that it didn't go out to your public Twitter feed, that it was made on a public platform. All social media networks fall into this thing. And when social media first started becoming really popular, actually after that, so it became popular, a lot of people started using it that didn't have backgrounds in technology. And then all of a sudden, when the reports came in that people were getting fired and suffering consequences in their lives as a result of things they posted on social media, when that first started happening, some of my friends and family came to me and were asking me about it. And I'm like, look, nothing you post online is guaranteed to be secret. And they're like, well, I only friend certain people and I make my account private and like whatever social network it was. And I'm like, okay, so what if someone that you're connected with or friends with is looking at something that you posted that's absolutely outrageous, immoral, viral, grotesque, whatever, and the person sitting over their shoulder takes a picture of it with their phone.
Right.
I'm like, where's your privacy now? Understand that no matter what you've done with your air quote privacy settings, that the shit that you put online is public forever.
Right. I mean, it's just like, I mean, people were, I remember when Snapchat first started.
Yeah.
And people were asking me like, so is this really secure? If I tweet somebody, it's going to, or I whatever you call Snapchatting somebody.
Snapchat someone.
If you Snapchat someone.
Don't show your age. Use the right terminology. If you snap someone.
But I was immediately the first
if you snap someone in the weep hole, they get really mad.
Oh, yeah. Boy, that'll bring tears to your eyes. Snapchat.
It's really bad when Doug and I get in the studio and we're on our second bottle of wine.
Snapchat.
I remember hearing about that Snapchat. Things were supposed to disappear like in however many seconds or minutes. And then, so I was like, I didn't believe it. Then I started Googling for archives of Snapchat photos, and lo and behold, there's a crap load of them out there. So much for them disappearing.
The first thing I thought of was just video. I mean, videoing as it goes by. Right. I mean, I could set up a video camera on a tripod and just sit there and capture every bit of it. I'm like, it's not. I mean,
they did have protections later that you couldn't screenshot.
Yeah, they won't let you screenshot, but you can still set a video
but
camera.
But I'll have to say, Android is a pretty open platform. Yeah, I have to imagine that there's probably ways around it. Snapchat could have the most secure, air quote, secure app in the world, but once you drop it on Android, we've all seen an insecurity that an application can be tricked into doing a lot of things because the platform has bugs and holes that can be exploited.
And I knew people that were trying to capture that stuff for surveillance purposes.
Sure.
I mean, they were, and so, yeah, I mean, it's all out there somewhere. I mean, good luck.
I mean, you're putting it on somebody else's server.
Yeah. That in of itself is a bad idea.
And when other people see it, they can certainly save it. It is some of my friends on Facebook post the ridiculous Tinder things, and I'm just like, I don't understand the whole thing. I don't know. I'm married.
So, have you guys seen the movie Chef? CHEF.
No.
Jon Favreau.
No.
I have. Yeah, but he's got a food truck, right?
Well, but you remember, it starts off. He thinks he's sending a private tweet that gets retweeted 32,000 times.
That's right. Yeah,
pretty good example of social media not being understood. It's also an awesome father-son movie, by the way. Gets me every time. But I was just thinking about it. It's a good example of what can go wrong when you just think you're sending something private that ain't.
Yeah, seen several people fired for stuff like that.
Yes,
I fired a couple of them.
Oh.
It's like your upper management does not have the guts to come in and tell you you're fired. So they hired me to do it instead, which is fine.
We fixed the payroll system.
I'm trying to find something as equally interesting to talk about. Lee, do you have stories that are...
Well, I thought we might have a little interest out of my #1 news story. There's this... So some people, if they have some of their cell phones, and we know we all get scam photos. I mean, phone calls on our cell phones
And
all
photos.
the time.
and photos and text. And now you may see something along the lines of scam lightly as the scam likely. This is a great
Yes.
line as part of the caller ID. And
Now I have Lee, just to
Yeah, go ahead.
clarify there. Android natively in Android it will mark calls as
Yeah.
spam, potential spam, and I have Truecaller,
Yeah.
and that will also. They kind of been working in tandem. Like usually, if one doesn't get it, the other might, but they both
Right.
still miss things. And
Right.
when you're in situations where you have to pick up your phone, right,
Right.
and answer every call regardless, I wish that the FTC would step in and put more stringent guidelines and regulations in laws in place to make it so that when your financial firm is calling you, there's some like DNSSEC. There's some way to validate that it is my my investment, my
Right.
local bank, whatever it is. But it doesn't when the caller ID comes up. It could be friggin' anything, and caller ID is rendered completely useless. Sorry, Lee, I didn't mean to steal your thunder, but
No. It's cool. You made the point I want to jump on, and that is there are these two standards out there called Stir and Shaken,
yes,
and
Yep.
what they basically boil down to is your phone or the VoIP gateway or other endpoint device that's basically routing the calls outward has a signature so that you know it's a genuine call.
Well, so
And-
Lee, was this the one that was just put recommended by the FCC and Amit Pai? That's the FCC chairman.
I think
Yeah.
that's
Was
the
quoted in the article, and
The
this
big
is something
coffee cup, yeah.
they're pushing
Yeah.
for. Yes,
Yeah, the Reese's Pieces.
The
coffee
Reese's
cup, yeah.
cup guy.
and so T-Mobile, AT&T, Verizon, and what's the
Sprint.
fourth one are
Sprint.
all implementing something. Although I have the feeling that Verizon is doing something completely different, but whatever,
Interesting.
because they have to work together to cross-verify. But yeah, it's kind of they're doing it optionally because the hue and cry from the users. And of course, I expect you're going to see a basic level of protection. And for a small monthly uplift, you can get an improved level of connection that includes not only AI but machine learning. Well, they're
No,
not
hold on. You made that
right?
last part up because
It does
Yeah.
Fourier transforms on your phone numbers. Converts them into quantum numbers.
Yeah, there actually is a hard problem to solve.
It is.
There is a
No,
lot
it's a
of
very
logic.
hard in the VoIP world. It's a very hard problem to solve because I can set up all kinds of
caller
fake
ID spoofing is ridiculous.
I mean, I can jump on Vonage or any of these services and change my numbers at will to any area code, so I can call you from a local exchange. So you think I get calls
Oh, God,
constantly.
it used to be years ago, a few spam calls that you'd get, you'd be like, oh, that's a local number. I'm going to pick that up.
Right.
You fast forward to today,
All of them are.
like 90% of the spam calls you get are spoofing your local exchange.
Exactly.
You know what's really
And
funny
local
about that
prefix.
to me?
Area code and prefix.
Yep.
For those of us that are road warriors, it doesn't work because we get calls from all over the fucking world. So it's like, yeah, whatever. But for those of us that are not, which is the majority of the population, let's face it, it damn well works, and it's annoying as crap.
But Joff, even if you're traveling, how do you know it's not your local dry cleaner calling you, or if it's someone that wants to renew the insurance or warranty on your car, right?
Well,
Like
I
you
ignore
don't know
99% of my
that.
calls
And I
anyway.
use the dry cleaner example because I got someone else's dry cleaning, which is kind of interesting. It wasn't really that interesting. I got a bunch of dress shirts that weren't mine, and I took it back, and they gave me my dress shirts. But had they called me, I'd have looked at the number and gone, is that the dry cleaners? Because it doesn't always map back to the business that's calling. Because I've gotten legitimate calls locally that I didn't answer, that I was like, shit, I probably should have answered that one. And the caller ID didn't match who it was. So I feel like there's two things. I actually, God, I can't believe I'm going to say this. I agree with the FCC's proposal that they should impose restrictions and laws that prevent organizations from spoofing caller ID. That seems logical to me. What also seems logical is to go the other way and require, I mean, let's start with the obvious ones. Require financial institutions, when they're calling a legitimate customer from that financial institution, to present a valid caller ID that is somehow verified in the proposal that they have forth today with stir and shaken.
Well,
right?
I think you have to put a certificate on each end, and that way the certificate validates, and at least it's harder to spoof it in the way it is today. I'm not sure the FCC can do it, because if I just offshore it and I make all the calls from India or Liberia or wherever, I can still spoof it, and the FCC can sit there and go, "You stop that," and unless they're willing to go to war over it, which they're not.
Yeah, because you got to trace it back to who's the U.S.-based firm that hired the external contractor.
PBX in Monroeville or Monrovia or whatever.
Doug's right. It's an implementation weakness, right? And if this thing was mutually authenticated before you can transmit caller ID, it wouldn't be a problem.
No, right? I'm not saying I would even then trust my caller ID to when someone financial institution calls me and says, "What's your social security number?" Well, hold on, you called me. No, screw you. Hang up. I'm calling you back.
But if we each just had a certificate and you knew who to trust, you could see a certificate from me, and I call you, and it's just Doug White is calling, and you would at least know that was me, and it would be a lot harder.
I still wouldn't give you
wouldn't. He wouldn't answer my call, but at least you.
But I wouldn't give them any personal information until I called them.
It's a certificate. I mean, I'm just saying though, it doesn't. It's not a trust thing. It just validates what it says on caller ID. So if it says Doug White, it really is Doug White. And if your phone says,
so then I know I can just send it right to voicemail.
Exactly. Yeah. And if you know, or you can just send me a dick pic back or whatever, like you usually do. But
text me first before you call. If everyone just texted first before they call, I don't know.
That's what I do.
One of the cool things in the stir and shake and stuff is it actually has different levels of assurance. So is the certificate at the phone? Is it at the PBX? Is it at the VoIP gateway? You have different levels of confidence.
Well, yeah, I'm thinking that the certificate.
System, cool.
I mean, I would want the certificates to be for individual calls. A certificate should be on the individual phones. For a commercial call, it should be at the PBX level. So it would have to say, "This is IBM calling," and or it says just random caller or non-secured certificate or whatever, and you could at least just send those to voicemail, and you don't have to answer them.
It almost feels like we need one more piece of information in the caller ID, and that would be something like the level of certainty about how genuine the call is.
Yeah,
maybe I'm overboard, but
that every spam caller just needs to set the evil bit in their caller ID so that we know that they're
that's right.
Evil.
Oh, they gotta set the evil bit.
I think I saw in one of the articles I was reading. They estimate 50% of mobile calls are scams.
Yeah,
right now.
Yeah,
which is crazy.
I'd say that's pretty accurate.
I mean, I put a product on my phone and it really stripped it out.
Do you want to?
Nomo Robo.
Nomo Robo.
It costs.
I'm using Nomo Robo as well.
It costs very little, and it really cut down. I was getting so many calls every day that were just horrific.
I'm in the horrific status.
Yeah, right now. And that really just, I mean, it went away.
That's good.
And I still get them on my office phone, but it's like the only ones I get on my office phone, which has a non-cool Manhattan number. I have a 646 number instead of a 212 number but my 646 number, if it's got a 646 area code, I don't answer it because I know that's a robocall.
Right.
So
right. But they have a non-mobile version of Nomo Robo. You're basically setting up simultaneous ringing at Nomo Robo and your extension, and they do the equivalent of picking up the extension and hanging up on them.
Right. Which makes them pay for the call.
Yep.
Yeah. I don't know that they have to pay much, but in the old days, back in the past, it was. I remember calling my girlfriend long distance, and we had a system for that. And you call a collect call, and then you yell over the operator, and they get mad at you. You go, meet me at 8 o'clock, and hang up. And then the operator would call back, and go, don't do that. That's illegal. And it's like, oh, I'm sorry. I was actually yelling at my brother. I wasn't trying to,
That's a hack. That is
talk about an old hack. We also had the one where you ring the phone. You ring the phone twice and hang up. And that meant, like, I'll meet you at 8 o'clock. So that way they didn't pick up the phone.
The days before text messaging.
Yeah, exactly. Our version of text messaging.
Did you ever make a call using a ham radio patch?
No, but I know what that is because I also have a friend who used to do that kind of stuff.
Wait, how do you do that, Lee?
Well, basically, it's like the ham operator in one location contacts another ham operator in the other location, and they're connecting it up. Then and the other operator calls you on the phone and sets it up, and it's essentially
call over radio.
You're on It's call over radio, but you're also on it's using the voice activated switching and stuff, but you have to like say over it when you're done talking, so that people know when to cut over, and you're not a private conversation anymore.
Right. Well, were you really
free?
Were you really a private conversation, Lee, in any situation over the old POTS systems?
Not unless you were really
Again,
naive.
I'll reference a George Carlin joke. Remember when he's talking about people tapping his phones? And he used to answer the phone. What did he say, Doug? Do you know the line?
No.
He said, "Fuck Hoover." Hello, hey, how you doing?
Oh, that's right. Yeah.
Yeah. Those were the days. But it was at that time we were living in Hawaii, and my family was here in California, and so it was wicked expensive for that long distance call. So the patch call was great, and you can still get the technology to do it.
That's
I'm
pretty
sure
cool.
that technology didn't go away.
No,
or you could just talk over the internet.
Yeah,
it's like free,
right?
Exactly.
Pretty much.
And because it's on the internet, of course, it's more private.
You just have to go do it at a public library. So
there you go.
These just aren't as interesting as what we've been talking about. I got on patch flaw on Cisco leaves small businesses wide open. PHP pair has been hacked, and the tainted package manager has been distributed for 6 months. It makes me think. I'm like, oh shit! I ran the.
I'll be right back.
God damn it! I ran the PHP pair command. Fuck! Now I got to go check some of my systems. Pair is like the package management system for PHP, right?
It's like apt. It's
or
like apt or
what is
yum
it in Python? I don't
know what it is.
Holy shit! What is it in Python, Joff? The package manager installer. Pip. Thank you, Pip. We both thought you said it as I thought of it. Pip.
Yum.
Pip is to Python what pair is to PHP.
And it's tainted.
PHP.
And it's tainted. Is it hobo?
It's hobo tainted.
Did we have that hobo conversation on air? Probably
God,
not.
I hope not.
God, I hope not.
That's why the FCC keeps calling my phone.
It was my Halloween costume. That's all I have to say.
Hobo in summertime.
Hobo leg ho tainted. Yeah.
Okay.
Can we wrap this up?
No, Joff, we still have time. I'm keeper of the time here, all right?
He's keeper of
All right.
So he's the head hobo in this place.
The head hobo is very accurate.
He's the taint master.
The taint master of the universe.
I really thought this one came from the Register because of the title. Turns out it didn't. It came from Ars Technica. But a researcher discovers state actors' mobile malware efforts because of YOLO OPSEC.
YOLO.
I'm not sure what constitutes YOLO OPSEC, but OPSEC is important. And it seems that if you're an evil, bad person, malicious actor, and you're not paying attention to your OPSEC, in today's day and age, you run a really big risk of getting caught. I think that, would you agree in general that attackers have to have slightly better OPSEC because there's more awareness in potential places
I
to
would
get caught?
absolutely
Right?
agree with that, yeah.
Yeah, I think even generally, like, what's your six?
I mean,
right?
people...
Well, I mean, Joff, you break into enterprise networks for your job, right? Like,
Yeah.
if your OPSEC isn't good, you might get caught. I mean, slightly different scenario, but still, if
No,
you're
you
not
gotta
using
watch your
encrypted
OPSEC,
channels or that kind of thing.
People
No,
have
it-
logging. They have, they have cameras. They have logging.
Well,
they have,
we've always had logging. I think now
people use
more
it.
people look at
That's
logs
what I mean.
for
I mean-
security events.
Yeah. So I think people do watch for that stuff. And if you were just out there wide open, I mean, I did a police case recently, and the person was caught because their IP address was exposed.
Right.
And they got notified that they were being investigated, and they still didn't.
If you don't have
obfuscate it.
basic OPSEC, you get.
And
I
that
mean,
person-
I remember back in the day at university. Well, this seems to be the episode that will live in the past. But It helped with an investigation that ultimately led to people who were convicted and sent to prison. And it was a failure on OPSEC. I was observing events in my network, and I was like, wow, that's a really weird FTP connection on a really weird port coming from a system that, based on other events, I know is compromised by someone else. Let me go on that system and see what's up. And in some of their scripts, they were automatically connecting to an FTP server. And so in that connections, because remember with FTP, you could have like a connection script that would automate it. In those files that I found were their usernames and passwords. I presented after, some process, like basically I called someone up and they were like, oh, I think we have someone working on that's in a different country. Hold on, I'll get back to you. Like literally in less than an hour later, my phone rings and it's, and I'm trying to anonymize it, even though it's been published. Anyway, it was Secret Service. They called me from Milan, Italy, and they were like, yeah, we're interested in what you got. We exchanged PGP keys, and that was basically one of the things that broke the case wide open. And because I sent Secret Service the username and password to the attacker's FTP server where they were stalling all of their malware backdoor scripts and all that stuff, they basically pulled all that down and were essentially laughing at the attackers. They had collected enough evidence to prosecute them, and it was successful. But that, again, goes back to OPSEC. Even back then, and we're talking this is in like 2005 or 3 or whatever, right? Even back then, if you made sloppy mistakes like that, someone that was paying attention could likely find you.
Yeah.
Fast forward to today, your OPSEC game has to be at a much higher level.
Because even average users now are aware of OPSEC stuff.
They're aware that hackers exist in the world. Right?
IP, they know what an IP address is, and if they don't, they can jump on Google and type it in and go, "What does this mean?" And I've had people call me,
Doug. Yeah,
I've had people call me and say, "What is it? What is an IP address? I've got one. This person keeps doing this stuff, and we captured it on our. I looked up how to capture it, and I turned my little Soho router on logging, and I've got these addresses. Is there a way to find out where those are?"
I know. And props to the people that are. I'm thinking of specific people who like really just shred attackers that even have really good OPSEC. I don't want to diminish in any capacity what they're doing. I mean, that's friggin' awesome. But the fact that a lot of the other attackers that don't have good OPSEC, they're getting clipped, here and there, maybe more. It's tough to say how often they're getting discovered. I think it's more often than in the past, be my hunch.
Well, I mean, a lot of attackers are not Lex Luthor. They're the dumb guy who just, nobody, I always say, nobody ever walked into a mini mart with a shotgun and thought, tomorrow I'll be in jail for the rest of my life. But,
it's true.
And there's attackers like that too. They're just not very smart, and they go,
not sophisticated.
Nobody's attacking this entity going, tomorrow I'm going to jail. And when they don't have OPSEC, they get caught because people are watching for them, and they have mechanisms to look for that. They have resources to turn to.
And people still do, but you're absolutely right. It's a great analogy. So let's bring that into bank robbery. Right? How many bank robbers get away scot-free, don't get caught, right? Like, it's a very, I'm sure there are.
Still do it.
It's a very small percent, very, very, isolated cases where you watch the documentary on History Channel of, like, the one bank robber.
D.B. Cooper. But even D.B. Cooper didn't get away with it. He died. His parachute didn't open or something. They found his, his remains or whatever.
Right, and there's lots of stories like that. But most people that rob a bank, and you hear stories and watch the local news or whatever, there's cameras.
But they still try
and they still do it.
Because
you still hear about a bank being robbed.
You know what, man? I tell you what, man.
That's where they keep the money.
I got all that money in there. I tell you what we do. We put some of our pantyhose over our heads, and we go in there with a couple of shotguns. We're going to be rich, man. We'll have so much meth, it'll be crazy. And then they go try to rob the bank, and, I had no idea I would be in jail for the rest of my life. It's like,
that was interesting. That was kind of the premise of the whole notion of offensive security and active defense. Was one of the principles was, well, one of the reasons why you catch a lot of bank robbers is you put the die pack in the money that they take, right? And there's a digital equivalent of that today as well.
Right. And I mean, you can do stuff like that. There's all kinds. But like I said, and just the fact that people have resources to turn to. 20 years ago, most companies did not have an idea who they could call to ask for help.
Right.
Today, there's companies that do this. If you Google, help me with, somebody can come help you forensicate your logs. They can prepare evidence. They've got all kinds of. You call the state police in Rhode Island. They have a great unit over there. You call over there and say, "Look, I think we got hacked." They can come over and take that data.
If there's enough damages at stake, I agree. We're transitioning off this, but I like where we're going. If there's enough damages at stake, you can get help from law enforcement. And I agree. In the past 20 years, I want to get your take on this. Past 20 years, law enforcement has significantly upped their game.
Oh my
in
God!
cybercrime. Like you think about how long we've come in 20 years, Doug, in investigating cybercrime across the board. All of law enforcement, state, federal, local, government, the whole thing.
I mean, I guarantee you, even 10, 15 years ago, and Rhode Island, shout out to Rhode Island, was one of the first states that really had a sophisticated computer crimes unit because they happened to have a couple of people over there that were really interested in this.
John Alfred.
John Alfred.
He's a great person. We met him.
Ken Bell and those guys. They were building. Ken Bell was one of the people that built that program. But I mean, you know, and you call them and they will talk to you about it.
But there has to be enough. It's a prioritization.
Well, they may tell you that we can't do much because it's such a dinky thing. But
correct.
I mean, 10 years ago, 15 years ago, if you called your local law enforcement and said, "I think I got hacked," they're like, "With a machete or what? A lawnmower blade?" Because I think I'm going to have to kill you.
And even today, I've seen a lot of harassment cases that, given better technology and expertise and effort, probably could lead to some type of prosecution.
Well,
right?
I'll give. I can't tell you much about this, but I did this law enforcement thing, and this case was very long. It had been going on for years and years and years and years, and a lot of the early investigation of this case was essentially people saying, "We don't know what to do. We can't help you." But over time, a really great detective got involved in that case, and because there were tools available and resources available to that person, they were able to put that case together. And after many years, they closed it, and it was because of OPSEC. I mean, the person did not use good OPSEC, and otherwise they would have got away with it. But because they just didn't have, they were the guy with a shotgun in a 7-Eleven.
It's interesting. I want to go back to what Chris Morales was saying between data scientists and security people. Security people have that knowledge of what to look for and why. The data science has that, like, how we look for it. When we look at law enforcement, in your case of the detective, in a lot of scenarios, that's flipped. There's someone who's been a detective or an investigative agent for 20 years.
Right.
That experience is so valuable to someone who's skilled in computer security that that's a great kind of marriage that can lead to a lot of convictions. And I feel like a lot more of that is going on.
And they smartened up on it because you saw then the FBI and people like that starting to hire people like you, because they knew that even though they had these great investigators, the investigators didn't know what questions to ask.
Right.
They knew they needed to ask a question.
Right.
And they knew about that behavior.
Their investigation skills were, and
awesome. I've had investigators say to me, "I know this guy's that did it."
Yeah.
I mean, you can tell from talking to this guy, he did it.
They have that intuition.
But it's like, I don't know what he did, and I don't know how he did it.
The technology or anything, but
and
they
literally,
just got feeling,
I've written a question or two for them and said, "Ask them these two questions, and then tell me what they said." And they call me back and said, "Here's what he said," and I was like, "Oh yeah, he did it."
Yep.
I mean, just very, I mean, but they've learned, and so that means you better up your OPSEC game if you're playing.
Yeah, to come back to the story, you're absolutely right.
I mean, because if you're not using good OPSEC, you are probably going to get caught. I mean, a lot.
If they don't know, they know who to ask. Whereas before they didn't know who to ask or what to ask.
And they didn't even have resources. I mean, but now they do, because now they go, "Oh, I know a guy at the university who teaches cybersecurity classes. I watch Security Weekly. I mean, I know a lot of law enforcement people who watch this show or listen to the show." And, they say, "I don't always know what they're talking
about."
Yeah, right.
Yeah, well, they're taking notes about you, Jaw. But
yeah.
there's going to be a wall to deal with your type soon. And, but I mean, I think law enforcement's really upped their game. They've found resources. Corporate has upped their game. They found resources. They got people on staff. They've got units, and because of that, I think that if you're playing these games, you're pretty much the guy with a shotgun and a 7-Eleven.
I mean, on the flip side of that, there's a lot of attackers that have had great success. I think the investigations have gotten much better, but that doesn't mean there's still like this database of 24 million mortgage loan records left exposed online.
OPSEC goes both ways.
It goes, yes. That's actually summed up very nicely, Doug.
Yeah, it is. It is. It's funny. You ever had that experience? If you're an information security professional in the field, somebody will often come up to you, party or something, and say, "Hey, man, I'm glad you're on the good guys' side. You know, if you ever turn bad, it would be really bad for the rest of us." And my typical response is, "I'm actually not that good. I'm good." But if you're on the bad side, your OPSEC has to be near fucking perfect.
Yeah. If to not get caught, sure.
You're going to get busted otherwise these days.
Well, and so many people will come to you and present a scenario, and you're like, to execute that scenario, to hack this thing or get that piece of information, you realize that could be months, maybe years of work. And as Joff said, your OPSEC has to be perfect to not get caught. And there are people out there trying to execute those attacks. Who knows how successful they are? Varying degrees of success, certainly. But there's a huge level of effort. But it's not, and I think Hollywood and movies and TVs have kind of done that a disservice, right? They think,
I agree.
To pull off like that big hack. In the movie, they show it like, they just type like they look like they're just mashing the keyboard.
And Swordfish, where they're holding a gun to his head. He's like, "I'm hacking the DOD. Hang on. I'm going to shoot you in 30 seconds. In. And it's like, yeah, right. That happened.
Yeah. Right. It's just, it's Hollywood, right?
Of course.
I mean, and to be honest, in the pen testing field, this is sort of a sad statement on the industry. We tighten up. We stay pretty quiet in the beginning of a lot of our engagements, but we pretty quickly get noisy. And the sad statement on it, this is not directly related, but the sad statement on it is a lot of organizations don't notice. And it's like, oh, wait, man, we've been noisy enough that you should notice. This is purely from a metrics and sort of threat hunting perspective. But, but the thing is, even pen testers, a lot of us don't really have to practice really tight OPSEC. We just don't. The state of the industry is not at that level, right? That's just
even pen testers get the blues.
Well, and I think what the company you're engaging with knows who you are and all that stuff, so it's not a really fair.
It's not a fair comparison. Right? It's a different. It's contrived, right? It's a contrived setup example.
And that's a sliding risk business, though, too. I mean, that's about like how much OPSEC do you want to have, and how. So I mean, if they say this is the launch codes and we've got nuclear weapons ready to fire here, you probably want to make if you're trying to pen test them, you're going to have perfect OPSEC. But if it's some company going, so it's all about where they want you to be on the pen testing.
There is the drone strike threat. If you do hack something, someone's going to come.
Hellfire missile
is going to come.
Hellfire missile coming right down the chimney. There could be one on its way here.
Weapons going to come get you. Oh well, the fundamental, as much as pen testing is wonderful, right? But as much as we say we are going to emulate a real threat actor, there's a couple of big limitations. One is it's under contract, and the second is I got to stay within the confines of the law.
Yeah.
Inside of that contract.
And I think that's what I was clumsily getting at, Joff, was that that sliding scale of where you get to be. You say, do you want us to go all out and because if it's nuclear weapons, I'm like, yeah, break the law. I want you to test this. I don't want anybody ever getting in here. But yeah, as a contractor, you have to play that game. And it's how many hours do you want us to spend on this? Do you want us to spend 10,000 hours and then do what somebody might really do to you, or 1,000 hours because that's what you want to pay for? And it's a game.
There are real examples out there of pen testers that have said, okay, fuck it. Yeah, I'm going to break into your premises and steal all your gear.
Yeah. Guess
what? You just violated the law. Guess what? Customer's going to call the cops and you're going to get fucked. Right? I mean, you don't go across some lines, right? I mean, there are limitations.
Yeah. Right? Scope.
Yes, scope. Yes. Yeah. So, Lee, I like the new Android malware that uses it looks at the telemetry from the motion sensor on your on Android and determines if it's being emulated or not, right? I'm assuming that's the story that your story number 2.
Yeah, that was the one where I was looking at Android was it's trying to use the motion sensor input to tell if it's in a sandbox, so it just goes to sleep. If it finds it's on a real phone, it offers you a secure Android update that's really cool and does crypto mining for you. I just like the way that it was so stealthy. It just kind of and trying not to be detected.
Yeah, when we had Lenny Zeltzer on the show late last year, he talked about some of the evasion techniques or techniques that malware would use to detect if it was in a forensics environment or in a lab environment, right? And I feel like that's always a cat and mouse game, right? So like now, knowing this, if you've got a malware sandbox that's emulating Android, you know that you need to emulate the motion sensors as if it were a real phone, and then the attackers are going to go back and say, can I use some type of machine learning algorithm to figure out that is this an emulated motion data that's being fed to me, or is this actual motion data that's being fed to me by someone's phone?
Yep, I agree.
And one thing I was wondering is what happens if I turn off location services on the device, but then I thought, wait a minute, who practically runs around with their phone and never turns on the location services?
Yeah, and that's most likely spoofed, Lee, right? The location services in the emulated environment. It's a cat and mouse game, just like it is for malware on PCs as well.
Yep.
Yeah. But it's cool they're trying new stuff.
It is cool that they're trying this. I saw this article this week as well, Lee, and I thought it was cool. And I wondered about how far the cat and mouse game was going to go, right? Like how hard are we going to work in a forensics sandbox environment to emulate movement versus how hard are the attackers going to work to be able to detect whether the movement is being faked or whether it's actually real.
Yep.
And actually, that is a pretty good use case for some type of machine learning.
Yeah, it could
on the attacker. And one of the, and it's people giving presentations, attackers use machine learning too.
They do.
In situations just like that, probably.
How they up their OPSEC.
Right.
Wow, I feel like we just came full circle. That was beautiful, Paul.
That was beautiful. I don't think we can top that.
I'm crying here. I'm crying.
With that, we're going to end the show. I will turn Doug or Joff. Lee.
Oh, my
Lee
God.
Neely.
Take us out.
Lee. Thank you, everyone, for listening and watching. Lee Neely. Take us out.
And with that, our rhyme of security news and mixed in with porn memes, we're out of here. Catch you next week.